Hello, my name is Adi Khosrawi, and this is the Mastering Windows Server 2019 Hyper-V course. This course will provide you the necessary knowledge and understanding needed to plan, deploy, and manage Hyper-V. This is the entire lifecycle of your Hyper-V deployment. Sections covering the planning will focus on the requirements needed to set up your Hyper-V deployment. This includes the networking, storage, and security requirements. We will discuss permissions and roles and responsibilities. Finally, we discuss Active Directory requirements needed to set up Hyper-V. Active Directory is a key component for clustered environments. Next, we go over deployment. These sections walk you through common deployment scenarios from simple single-node deployments to multi-node cluster deployments. We will cover various network, storage, and security options available for your deployments. I will walk you through the options available, discuss how to choose the best options for your environment, and why. Next, we cover Hyper-V management. We discuss the tools available and how to use them for daily management tasks such as backup, monitoring, and troubleshooting for your Hyper-V environment. Finally, we will talk about containers. Containers are a key investment area for Microsoft in Windows Server 2019. Microsoft first introduced native support for containers in Windows Server 2016 with Docker. Lots of changes here. We introduce containers and discuss how they fit with Hyper-V in the last section of this course. First, a bit about myself. I have been working in the tech industry in one shape or form for over 20 years now. My focus has always been on infrastructure technologies. I began working on virtualization technology with VMware ESX 3.0. I have been using Hyper-V and helping customers use Hyper-V since it shipped with Windows Server 2008 R2. I call Canada home, where I live in one of the coldest capitals in the world, Ottawa. Do follow me on Twitter, as I often tweet about the newest updates in Microsoft's Hyper-V, System Center, and Azure. This course is structured into 8 sections to follow the plan, deploy, and manage objectives. We go through every section and introduce the topics. Where appropriate, I will also demonstrate the capabilities and the functionality. We begin with Section 1, Hyper-V Deployment Planning, where I provide a technical overview as well as walk you through the overall requirements from a network, storage, and Active Directory points of view. Section 2 dives deeper into networking and storage. This section is for advanced use cases, especially for multi-tenant environments. Section 3 focuses on high availability and the Hyper-V features available to provide high availability to your VMs. Section 4 is all about Hyper-V management. This is where we go through System Center and the awesome new Windows Admin Center. Section 5 focuses on Linux. Microsoft has committed to Linux as a first-class citizen, meaning providing the same level of support to it on Hyper-V as it does to Windows. Microsoft is one of the largest contributors to the Linux kernel, and Hyper-V is a big reason for this contribution. Section 6 is about upgrades. Windows Server 2016 introduced mixed mode clustering. We talk about this here and how to go about upgrading your Hyper-V clusters with Windows Server 2019. In Section 7, we focus on daily operational tasks such as backups, monitoring, and troubleshooting. Finally, Section 8 is all about containers, as I said earlier. You will notice I do not have a dedicated section to security. This is intentional. That's because I believe that security should be part of every discussion and every topic. My goal is to make sure you understand the security implications in everything you do, so security is part of every section. Windows Server admins are being asked to own the virtualization stack as Hyper-V is bundled with Windows Server. They are increasingly being asked to become virtualization admins as well. This video course is for the Windows Server administrator who wants to master Hyper-V to plan, deploy, and manage a resilient, reliable, and secure environment. Previous hypervisor experience is preferred, but it's not required. Knowledge of Windows Server clustering, networking, and storage concepts would be beneficial as well. Finally, PowerShell. You will notice I go back and forth in many sections between the user interface and PowerShell commands. Microsoft has invested significantly in both with Windows Server 2019. That said, it is unlikely you can manage a Hyper-V environment at scale without PowerShell. So make sure to familiarize yourself with Hyper-V PowerShell commandlets. That's it. That's the overview. Let's get started with the first section. In this section, we cover the items needed to plan your Hyper-V deployment. We first begin by providing an overview of the Hyper-V technology. We also spend some time to cover some relevant topics. I say relevant because they relate to Hyper-V in one way or another. In some cases, Hyper-V makes the technology or the concept possible. In other cases, it enhances Hyper-V functionality. In the overview video, I mentioned that some prior experience with hypervisor technology is preferred but not required. I will go over some very fundamental terminology. If you are an expert with some other hypervisor, this will be a good review for you. In this lesson, I introduce Hyper-V. I will want to make sure you are familiar with some industry terms and concepts related to hypervisor technology in general and Hyper-V in particular. I will walk you through the available editions, how to pick an edition for your needs, and why. Finally, I want you to become familiar with Microsoft's overall data center offerings and where Hyper-V fits into this picture. This is an important topic as it will help you better understand certain management choices later on in this course. So what is Hyper-V? Hyper-V is Microsoft's hypervisor. A hypervisor is software technology that creates logical equivalents of physical hardware components. A CPU or a processor becomes a virtual processor or a virtual CPU. A network interface card in a computer or a server becomes a virtual network interface card or a VNIC. A hard disk becomes a virtual hard disk, and so on. The process is called virtualization. So what is the benefit of virtualization? It allows you to run multiple virtual computers, typically referred to as virtual machines or VMs for short, on a single server, thus saving a lot of money on things like physical servers, network gear, heating, cooling, and data centers, and so on. Microsoft first bundled Hyper-V with Windows Server 2008, so they've had over 10 years of successful product releases with this product. This is a very stable and mature product. You can use it to host the most critical business applications. So what can you use Hyper-V for? As I said, you use it to host virtual machines, but that's not all. Hyper-V is a mature and feature-rich product. You can use Hyper-V to provide disaster recovery, for instance, when two Hyper-V servers or clusters are hosted at two different data centers. You can use it to provide portability for your virtual machines, meaning you can move one VM from one server to another without making any changes to the virtual machine. You can use it to provide remote connectivity to a VM's console in case network-based connectivity has failed to the VM. One additional benefit is security. There are several security enhancements possible with Hyper-V. For instance, you can enable secure boot of VMs to protect against types of malware attacking boot devices of your Windows or Linux servers. Microsoft has 4 editions of Hyper-V, 3 server editions, and 1 client edition on Windows 10. What you need to understand of the server editions is they have identical scalability limits. The only distinguishing factors are associated with certain features outside of Hyper-V. There are licensing differences relative to the OS of the workloads and the number of workloads which can be hosted with each edition. You will notice I use the term workload interchangeably with virtual machine in this course, by the way. Windows 10 ships with the client version of Hyper-V. It is a feature-rich hypervisor best suited for developer workstations. I do not cover this edition in this course. This course is focused on the server editions. Many of the features of the server editions will work with the client Hyper-V. Now, which edition should you choose? Remember, we are only talking about server editions. The first decision is whether you will host Linux or Windows desktops exclusively on the Hyper-V server. If the answer is yes, then you should pick the free Hyper-V Server Edition. This is a free version Microsoft makes available. Again, no scalability constraints on this edition. Only thing you cannot do is install additional software other than a list of very few exceptions like the anti-malware applications or monitoring applications. The only other restriction is should you choose to install a Windows Server VM then you would need to license that VM separately from Microsoft. This complicates your Windows Server license management, so if you are installing a Windows Server license, don't pick this edition. If you are installing one or two Windows Server VMs, the Windows Server 2019 Standard Edition is plenty. It is licensed with 2 additional Windows Server 2019 standard licenses. You can of course install Linux and Windows desktop VMs like Windows 10 on this edition. The idea behind Windows Server 2019 Standard and the Hyper-V Server editions is that you are licensing them for VDI environments or for small environments with 1-2 Windows servers only. This option may be great for branch offices, but not necessarily for a large data center. If neither one of the use cases previously mentioned applies, then you should go with the Data Center Edition as it is the most cost-effective edition for Hyper-V. Please note that this selection criteria is based only for Hyper-V. If you need to install other apps or roles, this approach may not work for you. Also, please don't pick another decision flow based on you wanting to install Hyper-V on the same server as another application. You will unlikely have a stable environment if you decide to group Hyper-V with other applications on the same physical server. Software-Defined Data Center, or SDDC, is an industry term referring to basically software-defined everything. Hyper-V virtualizes the server hardware, but what about the rest of the data center components? What about the firewalls, load balancer, and my favorite, what about the SAN or storage area network? SDDC aims to virtualize all these elements into software. This provides tremendous benefits in manageability. If you are using the software-defined storage products shipping with Windows Server Data Center, for instance. Do you see the benefit? If the Windows Server admin is familiar with Windows Server management tools like the user interface, the PowerShell, the Windows Admin Center, System Center, etc., then he or she can use these same familiar tools to manage every aspect of the data center. This is the promise of SDDC. Microsoft ships several components either bundled with Windows Server 2019 Data Center or are separate products to complete this SDDC vision. Hyper-V is just one component. In fact, I would argue that Hyper-V is the foundational technology for SDDC. I show in this slide the other elements of SDDC. I will refer to some of them in this course as needed, but our focus will remain on the red column here. As you could imagine, SDDC with all these products and services provides tremendous opportunity for complexity. Yes, that too. So the industry has moved towards something called the Hyper-Converged Infrastructure, or HCI. Think of HCI as a bundled SDDC solution. You would go to your favorite hardware vendor and buy a Windows or Microsoft SDDC solution, which is fully integrated. The vendor installs the servers, the disks, the network, the cabling, etc. needed to get you up and running. Microsoft recognizes this trend and has moved towards including HCI management within the management tools. What does this mean for you as a Hyper-V administrator? It means that you don't get to deploy Hyper-V potentially unless you work for the companies selling these HCI solutions. That said, you would still need to do the planning and the management of Hyper-V within an HCI solution. The key thing to remember about HCI is that it's an integrated solution. Someone already figured out how to get all this hardware and software installed. That's the value proposition. I can't not talk about cloud. So what is cloud exactly? This is the definition of cloud. The cloud is a platform. It's about self-service, shared resources, quick provisioning. That's what cloud is. It's not just asking for a VM and waiting 2 months for your IT department to provision one for you. Hopefully this definition clarifies that virtualization is not cloud. Virtualization is a foundational element. That's where it stops. Microsoft has a custom version of Hyper-V in their public cloud, Azure, for instance. But Hyper-V is not Azure. It's only a foundational element and enabler. One last term I want to make sure you are aware of is Azure. Azure is Microsoft's public cloud platform. With respect to Hyper-V, Azure can be used for disaster recovery and backup scenarios. You can also use Azure services to monitor and secure Hyper-V. We discussed these in the relevant sections Azure is only referred to the services in the context of Hyper-V management. Let's reflect on this lesson. Hopefully you understand what Hyper-V is and which edition you can choose. Hyper-V is not going to live in its own island. It's a key element of the SDDC vision of Microsoft, a vision best realized when HCI is adopted. Hyper-V is a key enabler for cloud technologies. In the next lesson, we continue planning by going over the system, network, storage, and Active Directory requirements. System requirement. In this lesson, we discuss general requirements. I then go through some specific requirements needed only when you want to use specific features of Hyper-V. So let's get to it. We first begin with general requirements. Here, I cover the requirements you need for every single Hyper-V installation. First one is a 64-bit processor with second-level address translation, SLAT, and virtual machine monitor mode extensions. Microsoft lists this as a requirement, but in reality, this is a common feature of all modern processors. Microsoft lists this here in case you want to use older servers to install Hyper-V on Windows Server 2019. By old, I would say any server class hardware older than 3 years may not have a SLAT processor. It may also have one. Intel and AMD have produced SLAT capabilities for years. In fact, Hyper-V on Windows Server supported SLAT processors, so that's over 10 years ago. The only difference here is Microsoft has been requiring SLAT for Hyper-V. The second requirement here is actually to enable hardware-assisted virtualization features of the processor. You do this in the BIOS or EFI settings. Unfortunately, many hardware vendors still ship servers with this setting set to disabled, so you need to go in the BIOS or the EFI and set it to enabled. Finally, only other requirement to run a Hyper-V server is a lot of memory and a lot of disk storage to host your VMs. There are servers capable of hosting multiple terabytes of RAM. Windows Server will let you have up to 24 terabytes of RAM. Hyper-V will let you create a VM with up to 12 terabytes of RAM. That is a big virtual machine. Imagine the kind of workloads you can host with this beast of a server. There are a number of in-memory databases which will happily use up that memory. In this slide, I show what I had to do to configure the hardware-assisted virtualization on my computer. I went to Advanced ECU Configuration. Here, I looked for Intel Virtualization Technology, and I just made sure it was set to Enabled. That's it. The next part of this lesson will focus on the requirements specific to certain features of Hyper-V. Windows Server 2016 introduced DDA, or Discrete Device Assignment. Why DDA? There are a number of certain instances where the overhead of a hypervisor, however low that is, just too high. Think of real-time applications like stock trading applications, where a millisecond can make you more money or lose money. DDA allows you to take advantage of certain hardware features to lower that latency while still taking advantage of virtualization. The thing to keep in mind with DDA is you need the hardware to support it. You need a graphics adapter that supports DDA, for instance. You need drivers for that adapter to support DDA and Hyper-VMs, because you need to install these drivers in the guest VM as well, just like you would on a physical server. Next, SRIOV. SRIOV was first introduced in Windows Server 2012. It's again another way to reduce latency and gain access to hardware directly from the VM. SRIOV is found in many server-class NICs, although in theory this is a PCI standard, so other types of PCI devices can support it. So, what do you need to get SRIOV and expose it to a VM? I am thrilled you asked that question. Basically, a set of advanced processor and CPU chipset features. I list them here in the slide. Again, two things to keep in mind is all modern server class CPUs like Intel Xeon processor have this capability, and nearly all modern server class NICs also support SRIOV. Bottom line is this: if you want low latency networking, ensure 4 things support it: CPU, chipset, the firmware, and the SRIOV device such as the network interface card. One final note about low latency and DDA. Microsoft has a feature called Remote Effects. Remote Effects is not DDA. While both need hardware to support it, DDA is very different. Your VM actually sees the parent GPU, and you must install the GPU DDA driver inside the VM. Remote Effects is really a remote desktop protocol capability for remote connectivity to a VM while accelerating the rendering for graphics-intensive applications. Remote Effects does not even need a GPU. I don't cover Remote Effects in this course as it's most appropriate for RDP scenarios for desktop virtualization. Shielded VMs is a killer security feature in Hyper-V. Let me tell you a story. You see, since the dawn of server virtualization, anyone administering a guest VM had to trust the hypervisor administrator. This is probably okay if both of these individuals worked for the same company. This doesn't work for multi-tenant environments where the hypervisor admin may belong to a different entity than the one for the guests. Picture this. You have a virtual machine like a domain controller hosting a database of usernames and passwords. A hypervisor admin can take a snapshot of that VM and bring it to his or her PC where they can use a number of brute force password cracking tools to get everyone's passwords. Well, how do you mitigate against this type of attack? Microsoft released shielded VMs and the Host Guardian service to isolate guest VMs and encrypt them so that a Hyper-V admin cannot read the content of that virtual machine. Just keep in mind that the data center SKU is what you need if you want shielded VMs. For shielded VMs and Host Guardian services, there are two types of attestation, essentially a hardware and a software-based attestation. The hardware one uses modern hardware, like TPM 2.0, UEFI 2.3.1 or higher. This is called TPM Trusted Attestation. It offers the strongest possible protections, but also requires more configuration steps. Well, what happens if you want HGS and shielded VMs without splurging on a shiny new server? Microsoft offers what they call an admin trusted attestation. It doesn't offer the hardware-based security as with TPM Trusted Attestation, but it still offers you the benefits of shielded VMs. You probably noticed I add this reflections slide at the end of each lesson. Well, that is because you are very perceptive. That's all. Actually, it's a way for me to summarize a lesson in very few words, but please don't just skip through this slide in future lessons. That's not fun. Keep in mind you should be able to run Hyper-V on any modern PC or server class hardware. Just go in the BIOS or EFI and enable the hardware-based virtualization. That's it. The next lesson in our Hyper-V deployment planning section will focus on networking planning. This is a lesson about how to plan the networking of your Hyper-V deployment. Networking is a complex subject, and I hopefully will make it easier for you to understand and learn. I begin with an overview of some key networking features of Windows Server 2019 and how they are used in Hyper-V. I then walk you through the options and scenarios of how to plan for a Hyper-V host's network. I cannot not talk about the virtual switch. It really is the center of all networking magic of Hyper-V. And finally, I discuss some planning elements of your physical network. Let's begin with our first objective and provide an overview of networking features in Windows Server 2019 and how they are used in Hyper-V. Teaming has existed on Windows Server for a long time, typically as a third-party utility or add-on. Microsoft began shipping native NIC teaming capabilities with Windows Server 2012. Teaming is simply a way to aggregate NICs to provide two things. First, resiliency, so if one NIC fails, another one takes over. And second, to provide improved throughput so you can combine multiple NICs to get higher throughput on your server. Teaming is a feature for any Windows Server workload to use and take advantage of. Hyper-V can take advantage of NIC teaming or expose it to guest VMs, Hyper-V being a great candidate for it. A couple of things to consider is that NIC teaming doesn't support features like SRIOV, native HostQoS, and TCP Chimney, as it offloads the entire networking stack directly to the NIC. Note that Windows Server NIC teaming isn't supported for iSCSI storage area networks either. NIC teaming is an amazing feature, and it's best suited for client traffic to increase host throughput to VMs. That's the best use case for it and Hyper-V. NIC teaming has three teaming modes: each differ in how they interface with physical switches and the teaming algorithms you use. Switch independent, as the name implies, has no reliance on the physical switch for NIC assignments. The NIC teaming stack also manages the network traffic distribution. It's the default configuration and the one I use most often. Why? Well, because I like defaults, and that's not the only reason. The real reason is because I can configure it regardless of what is the underlying physical switch and how it's connected to my servers. Switch dependent and LACP mode are both switch dependent. The Link Aggregation Protocol, or LACP, has been around for a long time and is used to aggregate ports on physical switches. Since both approaches require similar configuration on the switch and Windows Server, it requires very careful assignment between the Windows Server administrator and the network administrator. Yes, you would have to talk to the network team. By the way, you can team NICs from different vendors. Yes, it's possible, but not very common and probably not a good idea for production deployment to introduce that variable. You will probably hear me talk about this often in this course. I'm a big fan of maintaining default behavior and only exceptionally drifting from a default configuration. Why? In my experience, this is the best way to maintain a stable environment and every update from Microsoft. I do drift from the default behavior with some of Hyper-V's features. In the case of NIC teaming, the best recommendation is the default one. For teaming, one of the most reliable and best performing configuration for a Hyper-V server is the switch independent mode and a dynamic load balancing mode. No standby adapters, as all adapters are both sending and receiving data. In this demo, I will demonstrate how to configure NIC teaming. I have Server Manager open. Let's start by having a look at which adapters are available on this server. Of course, I will use PowerShell. I'm using remote management, as you can see here, on my HV01 server. Get net adapter to get the list of network adapters available on the server. And notice I have 3 physical adapters. Yes, this is on a Surface device, and I have a virtual one. So if I just format it with the name and the interface description, 3 physical adapters. Okay, let's see about teaming 2 of those 3 adapters. So you right-click, configure NIC teaming, and the NIC teaming interface shows up, just like that. So I start by creating a team. I select which interfaces, give it a name. I'm going to call it intranet team. And just to show you here, this is a default configuration. This is where you can configure teaming modes and load balancing modes. You can also configure VLANs if you have a different VLAN for your management VLAN other than typically VLAN 1. And that's it. Notice the status of the interfaces. Usually there's one that comes up as active right away. The other one takes a few seconds to go ahead and change state. And there you go. Both adapters are now active, are part of the team. We go back to our PowerShell and see the same thing. You will see that now there's a new interface of the team, intranet team, Microsoft Network Adapter Multiplexer driver. And that's it. The Hyper-V virtual switch is the foundational networking element in Hyper-V. It abstracts layer 2 switching in software as an SDN component. Hyper-V's vSwitch is extremely feature-rich. Think of a physical switch and the common set of features available to it, and Hyper-V vSwitch probably has it. The vSwitch also forms the networking layer between the VM, the NIC, and the physical switch. It provides a logical NIC to the guest VMs and forwards all Ethernet traffic to and from the VM and the physical NIC while applying a set of rules and policies. The Hyper-V vSwitch also supports Wi-Fi adapters, although this is most commonly for the client version of Hyper-V bundled with Windows 10. The logical switch is a management concept with System Center Virtual Machine Manager, and it is a way to describe common vSwitch configuration parameters in order to apply a standard configuration to any new or existing Hyper-V host. It helps ensure a consistent vSwitch configuration is applied to all Hyper-V hosts. Here is an example of advanced networking features available in the vSwitch. To use any of these, you simply configure it on the NIC's property window and the vSwitch takes over. Some features, such as the configuration of port ACLs, are only used in PowerShell. There are 3 types of vSwitches in Hyper-V. They are external, internal, and private. An external vSwitch connects to the physical network. An internal one connects your VMs to the Hyper-V host. A private vSwitch connects the VMs together, but no communication to the Hyper-V host. In this PowerShell example, I show how to read the configuration of a vSwitch and the net adapters on a Windows server. One thing to notice is this Hyper-V Virtual Ethernet adapter. This adapter is created on the Hyper-V host whenever you create an external or internal vSwitch. Notice here that the switch name called external or type external created also a vEthernet external interface. This interface is created so that Hyper-V can communicate with the guest VMs over this virtual link. There are 5 types of network traffic on a Hyper-V host. Host management is used to manage the Hyper-V host, and organizations typically limit access to this network through VLANs or perhaps a firewall. Your domain controller or backup traffic would be examples here. Client or VM traffic is just that, traffic to and from VMs. Cluster communication traffic is the network traffic used by Windows failover clustering to manage clustering. Live migration is the type of traffic Hyper-V produces to move VMs from one host to another. Storage traffic is the last type of traffic, and this refers to traffic to and from the storage array or arrays that can be over SMB protocol, iSCSI, Fiber Channel, or FCOE. I often get asked the question how to assign traffic to Hyper-V hosts. Well, I'm thrilled you asked that question. The recommended practice is to still isolate management, VM traffic, and data traffic onto separate NICs. The 2 contentious types of traffic is the clustering and live migration. Clustering uses very little network traffic, but it's crucial to the overall reliability of your Hyper-V cluster. Live migration uses a lot of network traffic, but not all the time. So what do? My recommendation is to keep these as part of the management traffic if and only if you have 10 gigabits or faster NICs. That is because it is really difficult to saturate these links when doing something like live migration or even system backups. And of course, use NIC teaming. This is what it would look like. We come to the end of this lesson. So how did you find it? Networking is one of these things where you either love it or hate it, but it plays a crucial role in your planning. Things to keep in mind. Decide on NIC teaming. Choose default behavior. Decide on which vSwitch security features are required for your environment. Choose a host networking pattern like the one I provided you. Please consider 10 gigabit NICs or faster for your Hyper-V host. They are inexpensive today and will make your whole user experience just awesome. And that's it for networking. Next is storage, another favorite subject of mine. Storage. Storage is equally important to networking. Both can make or break your Hyper-V environment. Like the networking section, I begin with an overview of storage in Windows Server. I give a quick overview of the advanced topics. I then explain the VHD and VHDX formats. I then go over the various approaches for storage connectivity available for Hyper-V. Microsoft fully embraced software-defined storage and HCI. This is further demonstrated with Windows Server 2019. The VHD or the newer VHDX format are the foundational elements. They are virtual hard disks that appear as single files on Windows file system. Hyper-V uses this format to represent the hard drives of guest VMs. A special use case of the VHD files is the shared VHDs. Ordinarily, one VHD file can be opened by one and only one VM. A shared VHD can be shared amongst VMs for clustered volumes. Hyper-V supports the classic and newer SAN-based technologies such as iSCSI, Fiber Channel over Ethernet. It also supports the scale-out file server, which is a purpose-built file service to serve applications as opposed to the classic file server used to serve files. Hyper-V is a big consumer of this service, and we talk about this in this lesson. Storage Spaces and Storage Spaces Direct will be covered in the next section. For now, know that they provide a combination of software and hardware features to deliver high-speed storage at a fraction of the cost of a SAN. Windows Server also provides the ability to replicate storage volumes a bit like SAN replication. This feature is only available with the Windows Server Data Center SKU. Finally, data deduplication. I discuss all of these features in this lesson except for the ones in arrows as I go through these in the next section. The virtual hard disk. VHDs, or the virtual hard disk, appear on the Windows file system in Windows Explorer as simply a file. You can mount a VHD simply by double-clicking the file in Windows Explorer. You can mount VHDs anywhere from Windows 7 through Windows 10 and Windows Server 2008 to 2019. VHD is the old format and VHDX is a new one. VHDs support disk sizes up to 2 terabytes and VHDX supports disks up to 64 terabytes in size. Shared VHDs, or VHD sets as they're now called, enable guest clustering scenarios where multiple VMs can access the disk. So, what do you use? Basically, always use VHDX unless you need to prepare a disk to use in Microsoft's public cloud Azure. At the time of authoring this course in the summer of 2018, VHD is your only option. Security tip: please do not mount unknown VHD files. Just put a USB stick you find at a bar in your PC. Just don't do this. In both cases, this is a recipe for ransomware or malware to infect your computers or servers. Let's talk SAN storage. SANs come in all shapes and sizes. In general, storage is the most expensive item in your Hyper-V infrastructure. Why? Well, because you never have enough, so you keep buying more. Hyper-V supports traditional SAN access protocols like iSCSI and Fibre Channel. These are tried, tested, and true technologies. SANs combine disks, then adds RAID technology for added resiliency against disk failure, and exposes it to Windows Server as a standard Windows disk through a number of driver technologies like multipathing or MPIO. SANs are typically not used in HCI environments where SDS implementations are typically the choice. VFC or Virtual Fibre Channel is another way Microsoft demonstrated their support for SDS. VFC creates a virtual SAN and virtual HBAs or host bus adapters as part of Windows Server. Hyper-V then exposes the virtual HBA to a VM, and the VM sees it as it sees a NIC. From there, you can configure your storage with familiar SAN configuration tools like MPIO. I don't see a lot of VFC implementations anymore since we have shared VHDX for guest clustering. What about FCoE? Fibre Channel over Ethernet is a technology with a lot of promise to converge your Fibre Channel storage adapter with your Ethernet adapter. While this feature is available, this is not a recommended approach due to the complexity of FCoE in non-HCI configurations. It's great in HCI, but complex otherwise. Driver reliability was a reason to avoid HCI also. Similar to how I described for a network pattern with one exception. If you are using iSCSI, please note the NIC teaming feature I described in the previous lesson is not supported with iSCSI. The Scale-Out File Server or SMB protocol scale-out is a feature Microsoft introduced in Windows Server 2012 as part of their SDS strategy. Scale-Out File Server is a new file server role with Windows Server. It is not the traditional file server role. Its purpose is to serve applications like Hyper-V and SQL Server. You store the VHD or VHDX files on a Windows file share stored on the Scale-Out File Server servers. Hyper-V then accesses it over the traditional UNC path name. It allows Windows administrators to use traditional tools like Server Manager and PowerShell to manage Hyper-V storage. You are starting to now see the power of the Windows admin becoming what Microsoft calls the Fabric Administrator. The Fabric Administrator can administer computer, storage, and network using Windows Server. Just like a SAN, where two controllers are usually packaged into a SAN hardware, Scale-Out File Servers are usually deployed in a cluster for resiliency and load balancing. Scale-Out File Servers takes full advantage of high-speed, low-latency networking like RDMA. Data duplication is a fantastic feature to help you save on storage costs. It's great and it works really well for static data and not for live data like Hyper-V VMs. I don't cover it in this course, but it's an important feature for VDI hosted VMs as data dedupe is actually supported for that specific use case. Hopefully by now you are getting sick of this pattern, but this is really the most effective one. Unlike iSCSI, NIC teaming and something called multi-channel where you can gain additional network performance are fully supported with Scale-Out File Server clusters and hosts. Security tip for you. Scale-Out File Server uses version 3.x of the SMB protocol and provides end-to-end encryption of SMB data, thus protecting against data tampering or eavesdropping on untrusted networks. Antivirus applications. For a number of years, I told my customers not to put an anti-malware application on Hyper-V servers. This is because, and to put it lightly, they all reduce the performance to unacceptable levels. I talked to my customers about defense in depth, about using Server Core, deployment option of Windows Server. This provides a reduced attack surface for your Windows Server deployments. I talked to them about enabling and leaving the Windows firewall enabled even on domain networks, and also about remote management of servers. I also encouraged them to evaluate the risk and ask why they put an antivirus software on a Hyper-V server. Today, with Windows Server 2019, Microsoft bundles Defender, which has been specifically tuned with AV exclusions for Hyper-V. It's still overhead, but it's a lot less overhead than previous generations of anti-malware applications. Storage is done. For now, that is. We have another section containing a lesson about advanced storage topics in the next section. While SDS is very prevalent today, I would highly encourage you to wait till we go over the advanced storage lesson before making a choice about storage. Windows Server 2019 is still hiding some fantastic storage features we need to know about. iSCSI and Fiber Channel are still going to be around for many years and are still effective storage solutions. Our last topic is about AD requirements. We need to plan for that, so let's get to it. The Active Directory requirements. Two objectives for this lesson. First, to make you understand the requirements needed for Hyper-V deployments. Second, and the last objective for this section, is to cover the Windows Server roles added when you enable the Hyper-V role. You will most likely create a Hyper-V cluster for your production deployments. Standalone Hyper-V deployments are very rare. For this, you need for your Hyper-V host to be joined to Windows Server domain. Hyper-V doesn't really care about the domain functional level or schema, as Hyper-V does not update your AD schema. Hyper-V's AD requirements are in fact Windows Server Failover Clustering's AD requirements. If you've ever worked with Windows Server clusters before, you probably saw me coming a mile away. Beginning with Windows Server 2012 R2, Microsoft began supporting what they call AD detached Hyper-V clusters. This is possible. However, it is not recommended as per the link shown here. Microsoft really did this for customers who want to run in a scenario of branch offices where it's very, very small Hyper-V clusters, perhaps 2 nodes only. Keep in mind that certain features like live migration, where you can move VMs from one host to another, aren't supported in this configuration. Another reason not to do this. Windows Server Failover Clustering requires for the cluster members to be member servers in AD and to have a cluster named object created. The CNO can either be created at the time the cluster is created, assuming you have the create computer object permissions on the OU container where the CNO object is being created. The CNO can also be pre-staged. I show you how in the next demo. In this demo, I walk you through the process to pre-stage your CNO object. Open up Active Directory users and computers, browse to the OU where your servers are stored, this is important, and create a new computer object. Give it a name. I'll give it a SVRCL name. Click on OK, and there you go. Next thing, I will go ahead and disable that object. That's because Windows Failover Clustering expects this to be disabled. I'll get a prompt confirming, and that object is disabled. Notice that arrow pointing down at that object. When you enable the Hyper-V role on Windows Server, you will notice the Hyper-V Administrators group is created. As you may guess from its name, it's a group with permissions to administer Hyper-V. So any user or domain group requiring access to administer Hyper-V needs to be in this group. Security tip, and hopefully an obvious one, do not grant virtual machine administrators permissions on the Hyper-V host operating system. If you have ever been through an IT audit, you know very well that auditors will nail you when you don't practice segregation of duties effectively. And this is certainly one use case of that. We are done with this section. We finished with a light lesson. AD is important for Hyper-V. I would highly recommend you set up Hyper-V in a domain environment. Keep in mind that it is a fully supported configuration to host a Windows Domain Controller VM, as long as they are Windows Server 2012 or higher. That's because Microsoft introduced changes with Windows Server 2012 domain controllers to make them virtualization aware. The next section goes deeper in some of the networking and storage technologies. Section 2 is here, folks. It's about advanced networking and storage. This section has 5 lessons, each with their own video. We begin with virtual networking. In this lesson, I cover a number of fundamental virtual networking components available in Hyper-V. The virtual NIC is an important topic, so I begin with that. I then walk you through the classic network isolation technique available in the awesome Hyper-V vSwitch, and that is the VLAN and PVLAN isolation. VMQ and RSS are key technologies needed to overcome the problem created with faster networking. You'll see what that problem is soon. I finished this lesson with an intro to Hyper-V network virtualization, or HNV. Microsoft and the entire hypervisor market for that matter began supporting newer hardware capabilities in the VM's hardware. Capabilities such as EFI and Secure Boot, for instance. They also began removing legacy hardware capabilities such as BIOS, serial ports, COM ports, diskette, or floppy drives out of that virtual hardware. Why? Well, because you can't buy physical floppy drives anymore, at least I hope you can't. Microsoft calls this modern version of hardware Gen 2 VM hardware. Windows Server 2019 still provides support for Gen 1 hardware in case you have a requirement to have a VM running with this legacy hardware. Gen 1 also happens to be how all VMs run in Azure as of this writing. Some advanced capabilities are only supported with Gen 2 VMs. We discuss one of these in the next topics, for instance. Keep in mind, guest OS VM support is needed for Gen 2 VMs. Think modern OS versions like Windows 2012 R2 or Windows 10 or modern versions of Linux. You won't be able to install a 2008 R2 VM as a Gen 2 VM, for instance. These will need to be Gen 1 VMs. The virtual NIC. The VNIC is the virtual network adapter. Every guest VM will need a VNIC to be able to communicate with other VMs. Windows Server 2019 supports up to 32 guest VNICs, so even the most demanding network routing application can be hosted as a VM on Hyper-V. The VNIC is where you configure advanced network features like DHCP guard, as we saw in the previous section. One change introduced in Windows Server 2016 is the ability to add a NIC while a VM is running. This is only available for Gen 2 VMs, but at least you don't have to shut down the OS to add a VNIC. You will notice that every VNIC is configured at 10 gigabit per second. This is regardless of what the underlying hardware of the physical NIC may be. This is simply the synthetic NIC driver Microsoft ships with Hyper-V. Next, VLANs. VLANs have been around for a long time, and as an experienced Windows admin, you likely have had to configure NICs with VLANs before. VLANs are supported in the Hyper-V vSwitch for all types of network traffic. If you specify a VLAN tag on a VM on the management network of a Hyper-V host, this VLAN tag must be configured on the physical switch connected to the Hyper-V host as well. The vSwitch supports both trunk and access modes. The recommended configuration is to typically have VLANs for management, live migration, or clustering, and trunk configuration for guest VM traffic to allow a small number of NICs to carry traffic for many VLANs. VLANs provide effective isolation for small or medium-sized environments. Limitations associated with VLAN tagging is the reason behind HNV, as you'll see shortly. In this demo, I show you how to configure VLAN tagging on the vSwitch and guest VM. So in Hyper-V Manager, let's have a look at the Virtual Switch Manager. We have our external switch. We can configure the VLAN for the management network right here. So that's when you typically configure the management network as an access port and configure it there. Now let's have a look on how you configure VLAN settings for a VM. So in the properties of a VM, go to the network adapter, and it's right there. Again, typically you would have a trunk port for the VMs, and you configure every VM's VLAN properties individually. And that's it. Private VLANs. Private VLANs were common in service provider networks as a way to limit or restrict uplinks on which a VM can communicate. Hyper-V provides support to PVLANs via PowerShell only to the three types of PVLANs: virtual machine queues and receive side scaling. Today's modern CPU hardware and operating systems support multi-core processors. Even though the hardware, the operating system, and the applications support it, the networking stack was traditionally bound to the first core of the first CPU of the system. So if you had a 4-socket server with 16 cores each, your apps used all 64 cores of your server, but your network was stuck to CPU core 0. The network hardware had to catch up. RSS was introduced as a mechanism to split up the computational overhead associated with networking amongst all available CPU cores if needed. That's RSS for received side scaling and not RSS like the RSS feed for rich site summary. There was a problem with RSS. It was not available to virtualized environments. A smart engineer at Intel developed a way for the NIC to virtualize its queues and split them amongst multiple CPU cores. Enter VMQ. On a Hyper-V host, VMQ is configurable via PowerShell. VMQ's config isn't as easy as turn it on and get it to work. It's actually turned off by default. It's also not available for NICs slower than 10 gigabit per second NICs. First, you need to figure out how many CPU cores does your server have. You can do this with WMI through PowerShell with the getWMI object commandlet. My system here only has 2 CPU cores. Don't count the logical processors. This is the hyper-threading feature of the CPU. Next, determine your NIC teaming profile. If you are using the default of switch-independent dynamic load balancing, then the VM queue configuration would use the sum of queues configuration. We take the number of CPU cores and this NIC teaming input. For a server with 16 CPU cores using the default NIC teaming config, that VM configuration would look like the sum of queues config as I show in this table. In this example, I split up the queues evenly between 2 NICs, NIC 1 and 2. I dedicate 8 CPU cores each. NIC 1 has cores 0 to 7, while NIC 2 has cores 8 to 15. Notice the max processor's PowerShell attribute specifying not the CPU core number, but the increment. If you are using another variant of teaming and load balancing, you may be using the min queues approach for which the VM queue configuration is easier and it's just one line. Hyper-V network virtualization. HNV is a key investment area for Microsoft in Hyper-V. HNV in Hyper-V is inspired by Azure and is exactly how Microsoft implements the isolation multi-tenancy in their Azure Stack product. HNV is designed to provide multi-tenancy, security, and isolation while overcoming the scalability limits of VLANs and PVLANs. HNV Stack in Windows Server 2019 is a complete one. It ships with isolation capabilities and protocols, as well as network functions, including the data center firewall and software load balancer. I actually cover HNV in a lot more detail in lesson number 4. Are you fed up with me talking about networking yet? I hope not. There's a lot more to come. Remember to use VLANs sparingly. The recommended approach of VLANs is to provide isolation for management traffic, including clustering, live migration, and the server management. Consider VLANs for smaller guest traffic isolation only or flat networks, and use HNV for larger implementations or where multi-tenancy is required. Our next lesson further explores virtual storage topics. In this second lesson, we delve deeper into virtual storage topics. In this lesson, there will be 3 topics we cover. I talk about virtual storage controllers, checkpoints, or snapshots as they used to be called in previous releases of Hyper-V. Finally, a discussion about file systems, virtual storage controllers. Just like the storage controllers in your server, these virtual controllers serve as the interface to the virtual hard disks and virtual CD drives. They are configured in the VM settings just like other virtual hardware components. 2 types of storage controllers available to Gen 1 VMs. That's IDE and SCSI controllers. IDE is the only bootable drive controller where you can have the OS virtual disk. SCSI can be used for data disks. SCSI is the only controller type supporting hot add of virtual disks while the OS is running. With Generation 2 VMs, SCSI is the only controller type available and IDE is gone. You can put your OS disk on the SCSI virtual controller. Let's compare storage controllers on Generation 1 versus Generation 2 VMs. I have a Gen 1 VM here running, so I will go to the settings of that Gen 1 VM and look at the storage controllers. Notice there's IDE controller 0 and 1 and a SCSI controller. 0 has a hard drive, 1 has a DVD-ROM. SCSI controller allows me to do a hard drive or shared drive while the VM is running. I can try to do the same with an IDE controller. Notice it's all grayed out and the message at the bottom is saying that I cannot do this because the VM was running. Not the case with SCSI. I can add a hard drive while the VM is running with Generation 1 VMs. Starts the wizard, asks me for some properties and so on. Cancel into that. Let's have a look at the Gen 2 VM. Notice only SCSI controller, nothing else. And same thing, I can add hard drives and shared drive. The OS drive is now on the SCSI controller. Same process, I can add a hard drive while the VM is running. Checkpoints. Checkpoints are a point-in-time capture of system state, a bit like a backup, except it also tracks the contents of the VM's memory. Even if you've never used Hyper-V before, you're probably familiar with this feature as it's been around on competing hypervisors for over a decade. Hyper-V allows you to take up to 50 snapshots or checkpoints of a VM and restore the VM to any of these. Windows Server 2016 introduced what's called production checkpoints. Production checkpoints actually leverage the same technology used by backup applications inside the guest VM to fully support checkpoints in production. Checkpoints need additional disk space, so make sure and plan accordingly. Hyper-V allows you to store the checkpoints data files on a separate storage volume than that of the VM. Let's create some checkpoints. This is Hyper-V Manager, what you use to manage your Hyper-V environment. I have my Hyper-V host, my VMs on that host, checkpoints for that particular VM, and some more information about that VM. If I look at this one, it has a checkpoint. I have some information here. Memory demand, for instance, I see it's low. Networking information, I see the vSwitch and IP address information on it. Replication information for Hyper-V Replica. Some Hyper-V server settings and the virtual switch settings. And the VM settings for that specific VM. Let's have a look at the settings of this VM. Let's look at the checkpoints. By default, we'll see that production checkpoints are enabled. That's where it uses the backup technology for in the guest operating system. And I can select standard checkpoints as well. I can change the location of where my checkpoint files go. Very good idea in production environments. And I can just go ahead and create a checkpoint. It says creating checkpoint. Now this is a pretty fast machine. Creates the checkpoint very quickly. I'll say OK. And there it is. At any point, I can apply that checkpoint, so go back in time. There you go. I create a checkpoint and apply. Saves it, creates another checkpoint, and it saves the state of that VM. Now in production checkpoints, it turns it back to off. I go ahead and start that VM in this current state. To delete a checkpoint, you just simply right-click it, click on delete, confirm, and delete that checkpoint to save on that space. It does a merge, so any contents from that checkpoint back into the VM. Let me show you the behavior of what happens with the standard checkpoints. Slightly different behavior, so let's try it. Same process to apply the checkpoint or to take a snapshot. It creates it. Again, with the date and time, you right-click and apply, so it goes back to it. Recommend create a checkpoint and then apply it. Same exact process, slightly different behavior. Once it applies it, it starts it again. And that is checkpoints for you. The final objective of this lesson deals with file systems. There are 3 file systems supported by Hyper-V: NTFS, CSV, and REFS. REFS, or Resilient File System, was first introduced in Windows Server 2012 with no support for Hyper-V. Today, with Windows Server 2019, Hyper-V supports REFS. It supports it on standalone, non-clustered volumes or with storage spaces, something I covered in the last lesson of this section. NTFS has been around since Windows NT. It's the default file system and the only one you can use for a boot disk. CSV, or the cluster shared volume, was specifically developed for Hyper-V clusters to allow read and write from multiple hosts to a single shared disk volume. It works with NTFS to create this. We cover it in more detail in the next section. For now, know this. For standalone installations, stick with NTFS and use the CSV file system for clustered installations. Also, consider using a larger block size for volumes hosting VHDs for added performance. Remember that Gen 2 VMs provide newer capabilities. Gen 2 VMs only support SCSI controllers. Also, do consider the impact on storage of checkpoints. Next, we look at the quality of service and how we can provide service assurances to our users. Quality of service is really about delivering a predictable performance as part of the service delivery. Windows Server 2019 with Hyper-V has two mechanisms to do this, for the network and for the storage. Let's begin with the network. For network, Hyper-V provides network bandwidth management at the network adapter level. Here, you can see that we can enable bandwidth management to guarantee a minimum bandwidth and maximum bandwidth for that specific VM's network adapter. This is only applicable in a scenario where the network is saturated. It doesn't automatically kick in. This provides a protection against a noisy neighbor problem where another virtual machine using the same physical NIC is using up all the available bandwidth. What about storage? Storage performance problems are very common. This is because this is one of the most valuable resources and the most expensive in a Hyper-V environment. Hyper-V provides storage quality of service at the virtual hard drive level. Notice how you can enable minimum and maximum IOPS as part of the quality of service configuration for a virtual hard drive. Again, this protects against that noisy neighbor problem where a VM is taking up all the resources of a specific volume. There is one additional mechanism for storage quality of service with the specific use case of using a scale-out file server. Here, you can create and centrally manage a VM storage performance policy. You do this by creating storage classifications using the new storage QoS policy commandlet to create different classifications such as gold, silver, and bronze. Each policy will have a minimum or maximum performance classifications as per the VM disk. Key thing to know, to protect from a noisy neighbor issue with the network or with the storage, you can specify bandwidth policies or storage QoS policies. Next, we will focus on advanced networking topics. This lesson brings the advanced networking and storage. I begin by introducing HNV and then go deeper into its components. First, the controller, which is the brain of all things HNV. We then go over the specific NFV or network function virtualization features of HNV. Encrypted SDN networks is a new feature of Windows Server 2019. I finally walk you through the HNV deployment with the SDN Express tool developed by the HNV product team. First objective is explaining what HNV is. HNV does to networks what hypervisors do to servers. They virtualize the entire network. Not just the NIC, not just the isolation like VLAN, it's the actual network. HNV has VM networks representing connectivity between VMs and other network resources. Network virtualization was designed to provide logical separation and isolation of virtual infrastructure to overcome the scalability of VLANs. It uses overlay technology to encapsulate network traffic. A big benefit of network virtualization is it allows for the hosting of overlapping IP address space since the packets are encapsulated. Think of service provider scenarios where multiple customers can be logically separated and isolated, and they can maintain their overlapping IP address space. Like any standard IP-based network, the VM network can have multiple subnets. HNV is in its second generation. Version 1 shipped with Windows Server 2012 and 2012 R2, and V2 shipped with 2016. They are incompatible with each other. V1 uses the NVGRE protocol, and V2 uses VXLAN to encapsulate the packets. V2 is the default with Windows Server 2019. Microsoft is not actively developing V1, so you should not use it for new deployments. You may be wondering, how does HNV V2 not get confused with overlapping IPs? How does it know how to route packets? It is because each network has an HNV RDID or routing domain ID. This value must be unique and is only known to the Hyper-V infrastructure. An RDID can be used to represent and isolate one tenant from another in a multi-tenant environment. Within each RDID or VM network, you can have multiple subnets as you would expect. Each subnet has yet again another unique identifier called the VSID, or the Virtual Subnet Identifier, to identify each subnet uniquely. In this slide, Subnet 1's IP address space from company XYZ can overlap with any of company ABC's subnets because they are on different RDIDs and have different VSID. Now, if company ABC and XYZ are partners and need to route packets from one subnet to another where both have overlapping IPs, then that would not be possible without doing something like NATing the IPs, which is another function provided by HNV. How does the traffic flow then? If two VMs need to communicate and both are on the same VSID, then it's simple. The vSwitch will handle that. Traffic internal to an RDID between two VSIDs is handled by the HNV's router. Traffic external to an RDID, so between two RDIDs or external to the HNV altogether, is handled by HNV gateways. You may be wondering how a Hyper-V host knows where to send traffic within the HNV infrastructure. I mean, which other Hyper-V host is it going to send traffic to? The hosts know more than that. Actually, every network adapter in an HNV environment is provided two IPs, a CA or customer address and a PA or provider address. A PA is unique to the Hyper-V host. A CA is unique to the virtual network adapter. Are you confused yet? Let's try and put it all together, but a few more topics to cover first. The brain behind all things HNV is the controller. The controller is just another server role that must be added to every HNV network. Don't go adding it yet. I'll be talking about a way to automate all the components of HNV deployment at the end of this lesson. I wasn't kidding about the controller being the brain of the whole thing. It really does everything from configuration to monitoring of your virtual network. It's a key component of your setup. It's deployed as a VM on the Hyper-V host participating in the HNV network. Microsoft recommends you deploy this in a high availability environment with a minimum of 3 distributed VMs across 3 separate Hyper-V hosts. In its simplest form, it's essentially a REST API endpoint. You can use System Center Virtual Machine Manager to deploy it, or the SDN Express, which is the recommended approach for Windows Server 2019. NFV is an industry term used to describe the virtualization of many network functions. Functions or appliances such as firewalls and load balancers. Guess what? Windows Server 2019 provides these as well. There is a distributed multi-tenant firewall, a software load balancer, and a RAS gateway for SDN. This is the gateway I referred to earlier, which provides, among other things, NAT capabilities and routing external to RDID. Like the controller, these can be deployed by SDN Express as well. You might be wondering, how is the data center firewall different from the Windows firewall that ships and has shipped with Windows Server for many years? The Windows Server firewall is an OS firewall that has the visibility and protection only to that VM on which it's enabled. The data center firewall has total visibility and traffic protection of your HNV infrastructure. It's a layer 3 stateful multi-tenant firewall, meaning it's aware of the RDIDs and the logical separation to filter traffic between RDIDs. One big gap, in my opinion, with the data center firewall when it first came out with Windows Server 2016 is the lack of standardized logging of packets, as this is typically required in enterprise and service provider environments. Windows Server 2019 addresses this by introducing a logging format compatible with Azure's Network Watcher. The SLB, or Software Load Balancer, is an NFV component available with Windows Server 2019. It is a layer 4 load balancer with rich support for features such as TCP and UDP load balancing and NATing support. Like the data center firewall, the SLB is managed by the controller and can be deployed by the SDN Express script. The data center firewall is amazing. The SLB is great and provides HA and load distribution for my environment. The RAS gateway, or Remote Access Server Gateway, is the traffic manager, really. When traffic needs to leave the HNV environment, for instance, from your data center to your user networks, that traffic needs to be routed through a gateway. The built-in RAS gateway supports a number of scenarios, including site-to-site and point-to-site VPNs and GRE tunneling. The BGP routing protocol is the only dynamic routing protocol supported by the RAS gateway. Static routing is also supported. A new feature introduced in Windows Server 2019 is the ability to encrypt VM network traffic. With Windows Server 2019, you can now encrypt inter-VM traffic within a subnet with encrypted network in SDN. It's still a great idea to also provide app-level encryption, but you now have this additional capability. Yet again, the controller to the rescue. Yes, this is again controlled and configured via the controller. Just remember, this is for traffic within a subnet within a VM network only. Anything leaving the subnet or the VM network is not being encrypted, even if that subnet has been enabled for the encrypted network for SDN. So let's discuss planning for HNV, and then I walk you through the recommended approach to deploy it. First, controller requirements. As a minimum, you need to deploy a single Windows Server 2019 controller VM. Although given the importance of this function, something you hopefully have seen by now, Microsoft recommends multiple VM controller deployments, a minimum of 3 in fact. Additionally, 2 local groups are needed for the controller admins and the network controller users. A requirement of the controller is the ability to dynamically register with DNS. If you are using AD integrated DNS, then this is a default behavior. If not, please ensure this is configured for this to work properly. Hopefully, an obvious requirement is that you need a bunch of Hyper-V hosts. The SDN Express performs a local deployment of all VMs of the HNV setup to a local Hyper-V host, which can then be moved to other Hyper-V hosts if they are clustered. You will need to define an IP segment for the provider network and the management network, so have these handy. Finally, you need the script itself from the GitHub repository. With the script downloaded, just launch it with the SDN Express PS1 script. First thing it will do is try to install the network controller management tools. Then the wizard pops up. Next, the VM creation. We supply the VHD source where everything is going to get installed, a prefix for all the VM names, and domain join information. Management network, as I mentioned, you needed to have this handy. You can supply a VLAN ID as well for your management network if you have one. Provider address network, so that's the provider address space for each one of the Hyper-V hosts in your environment. Network controller deployments, so a fully qualified domain name, whether you want a single controller or multi-one. Again, for production, please deploy multi-ones, and host credentials on that VM. Same thing for the software load balancer, how many you want, the VIP subnet, and the public VIP subnet as well. Gateways. Here, the SDN Express script rightfully forces you to create a minimum of 2. If you have any BGP protocol information like your autonomous system number, you can enter it here with the router IP address and its own autonomous system number. The last window allows you to review the information and, importantly, export everything to a PowerShell file. Why would you do that? Well, there are some baseline configuration items, like each VM will have 8 gigs of memory and 8 vCPUs. Maybe you want more, maybe you want less, depending on the size of the environment. That's where you can configure that in the exported PowerShell script and run it just like you would any other PowerShell. Once everything is said and done, you'll start seeing all this verbose output on your PowerShell window. Go for a coffee, get some rest, and come back a while later and you'll have all these VMs ready for you. What did you think about all of this content? You won't find a lot of content about HNV on the web. It's really focused on service providers who adopt this to provide cloud-like capabilities to their clients. HCI and Azure Stack are actually big consumers of HNV and pre-configured. In the case of Azure Stack, the hardware ships to your data center and Azure Stack is pre-installed by the vendors and is only configured to your environment. The HNV configuration is completely transparent to you, but you will be asked about the addressing, for instance, and routing configuration, so it's very important for you to understand how HNV works. Coming up in the next lesson is all about the advanced storage features of Windows Server 2019. the advanced storage features of Windows Server 2019. This section has 3 lessons. All 3 deliver on the software-defined storage strategy Microsoft first began delivering in Windows Server 2012. They are Storage Spaces, Storage Spaces Direct, and Storage Replica. Let's begin with Storage Spaces. Spaces is a component of Microsoft's overall SDS strategy. Spaces is used to combine many disks to create a storage pool. Why would you do this? You can do it to increase the overall resiliency of the underlying disk system or to increase its performance, or both. So perhaps you are wondering, how is this different from the RAID technology that's been around for decades now? Conceptually, it's very similar. RAID requires RAID hardware controllers, and they were often incompatible from one vendor to another. Spaces is all Windows Server. You manage it via the same familiar Windows Server tools. Spaces has evolved to support many technologies previously only seen as expensive SAN features, such as the ability to combine SSDs with hard disk drives to create storage tiers where frequently accessed data would end up on the SSD drives, for instance, to increase performance. Spaces is also available in Windows 10, accessible via the control panel. Dynamic disks in Windows Server is a legacy technology behaving similar to Spaces conceptually. Dynamic disks are deprecated, however, and should be avoided. Why am I talking about Spaces on a Hyper-V course? Because Hyper-V uses a lot of storage, and anything that can lower the cost of storage like Spaces is very welcome. Spaces is only supported via the SAS disk interface. So SAS enclosures and SAS switches would be needed for a clustered Hyper-V environment. Please note that while Spaces will function by combining any bunch of disks supported by Windows 10 or 2019, it is only supported on certified hardware. To find certified hardware, go to windowsservercatalog.com, click on Windows Server 2016. This site has yet to be updated with Windows Server 2019 hardware as of this writing. You then go to Storage, Spaces, then Enclosures. This will provide you the list of supported enclosures. This is what a typical Hyper-V cluster deployed with Spaces would look like. In this pattern, the scale-out file server cluster acts as the storage controllers connected via SAS to a storage array, typically over SAS switches. Hyper-V would connect to the scale-out file server cluster over Ethernet or RDMA. Storage Spaces demo. First, we go to Server Manager, go to File and Storage Services, Storage Pools. Notice we have Windows Storage. We have a bunch of disks, 64 gigabytes each, all connected through a SAS interface. No virtual disks yet. So we'll go ahead and create a pool. We'll give it a name. Assign it to the Windows 1 server that we have. I'll go ahead and select all the disks because I want all of them to be part of the pool. I can select hot spares. I will just go ahead and leave this as automatic, meaning all disks participate in the pool. And that's it. Very quickly, I can create the pool like that. I will go ahead and create a virtual disk as well. That's the pool I just created, 250 gigs. A new virtual disk wizard starts. Click Next. Give it a name. Notice it says create storage tiers in the virtual disk. I only have the SAS drives, so I cannot create different tiers. You'd need sort of something like an SSD and HDD. And this is not really an enclosure. This is part of a VM just for the showcasing of this Storage Spaces feature. 3 types of layouts: simple, where there's no failover; maximizes capacity; mirroring, where data is copied to twice or 3 times; maximum resiliency; and parity, where it's a combination of both. Gives me the striping over all disks. I can thick or thin provision this, meaning allocate all the data ahead of time or not. I prefer to leave it at fixed. Then the size of the disk within that pool. So to make things quicker for my video, I will go ahead and specify maybe a smaller size. I can alternatively just go for maximum size and create one big massive virtual disk to take up the whole 164 gigs. But let's leave it at something smaller. Let's leave it as something smaller, say 10 gigabytes. Next, and create. First, we created the pool, then the virtual disk. Now we create volumes on a disk. Just like on a physical drive, you can create different partitions. Same thing here. So we're going to go ahead and create a volume, and we'll create a volume that takes up the entire 10 gigs of space on that virtual disk. You can give it a drive letter. I will say don't assign a drive letter for now. Since this will host VMs, I will give it the maximum allocation size and give it a volume label. Next, and create. And just like that, we now have our volume. The next topic is Storage Spaces Direct, or commonly abbreviated as S2D. S2D is yet another software-defined storage technology. It functions by combining locally attached storage of network servers to create a storage pool. Like storage spaces, it is only supported on certified hardware. Unlike storage spaces, it supports SATA, SAS, and NVMe interfaces. Remember, they all have to be locally attached to the servers participating in the S2D cluster. Consider S2D's network requirements. You need low latency RDMA networking or 10 gigabit per second Ethernet for S2D to be supported. Finally, Windows Server needs specific combinations of fast disk types like SSD and NVMe. If you look at the table here, what do you see? A minimum of 2 SSDs or NVMe disks must be present in each server to maintain performance of the overall S2D pool. You also need a minimum of 4 data drives. Now, if all 4 drives are of the faster SSD or NVMe variety, then that's great and you can get away with just a 4 drive minimum. All your data drives are of the slower hard disk drive variety, then you would need to add 2 additional faster SSDs or NVMe drives for a minimum of 6 drives total. Bottom line is S2D needs this to provide predictable performance. There are 2 ways to architect S2D. One is the converged approach, where it looks somewhat like storage spaces with scale-out file server pattern. With the noticeable difference, as you see here, is each scale-out file server in the cluster uses its own local storage as opposed to using a SAS storage network. Each scale-out file server cluster member participates in the S2D storage pool using its locally attached storage. In the hyperconverged pattern, the Hyper-V servers are the S2D storage controllers as well. Fewer servers on the network, fewer networks, high performance and resiliency. It's all about choice. It comes down to how converged do you want to get and which Windows Server SKU do you own. Hopefully you see the benefits of the hyperconverged approach with fewer networks. Just keep in mind you absolutely have to have a 10 gigabit network with S2D. Final topic, storage replica. Storage replica is one of these features I first couldn't believe was included at no additional cost in the data center SKU of Windows Server. What is it? It's block level storage replication. It means you can take a storage volume and replicate it to another one in another location, and Windows Server and Storage Replica will copy it block by block synchronously or asynchronously. If you've ever used SAN replication or paid for it, you know how awesome it is to have this included with Windows Server at no additional cost. For Windows Server 2019, this is also included in the standard SKU, but limited to replicating a single volume up to 2 terabytes. There are a number of ways to configure storage replica. First, server to server. Probably not going to be a common scenario for Hyper-V. Only manual failover is supported in this configuration, as this is not a clustered setup. Cluster to cluster with shared storage at each location. In this scenario, you can have Hyper-V cluster in one location, replicate its data to another location. This is a great example of simplifying your disaster recovery strategy. Finally, a stretch cluster scenario where the cluster spans 2 sites. In this scenario, storage replica can replicate data volumes synchronously or asynchronously, and failover can be performed automatically, assuming you have a cluster witness at a third location or using the cloud witness feature of Windows clustering. Hopefully you can understand how feature-rich Windows Server storage capabilities are. Just remember, certified hardware is the key to success in your deployments. We are at the end of this section. Next stop, high availability. In this third section, we discuss HA, or high availability features available for Hyper-V. This section is about HA for both Hyper-V and the guest VMs. We have 4 lessons and I combine both guest and Hyper-V HA features in these lessons. We begin with this video with storage availability. The first topic and lesson covers features available to allow you to perform operations on your storage while maintaining the overall availability of storage to the guest VMs. We begin by reviewing some of the availability features we have seen thus far and then cover storage live migration. I want to begin by making sure we understand the terminology. HA is fundamentally about user experience. The users of your virtual environment expect resources to be available. Business applications are becoming more critical, which means you have to maximize availability of both your Hyper-V fabric, i.e. the storage, compute, and network, as well as the guest VMs. HA does not replace your backups or your DR strategy. These are different things with different business requirements. One key element of HA is the ability to do your typical operations like backups and patches without disruption to resources such as the guest VMs. Microsoft calls this continuous availability. I may not have called these HA or CA features, but we did cover a number of features to help with the overall availability of your underlying storage subsystem. HA or CA begins with the architecture of the storage subsystem. And if you are leveraging the parity or mirroring features provided by Spaces or RAID, then you are already providing HA against one of the most common and likely failures of your environment, and that's the underlying storage subsystem. Remember, disks fail. Not if, they will. So planning for this is crucial. So how do you plan for it? Again, by using parity or mirroring in RAID or Spaces. Let's review the availability features of Spaces. I mentioned in section number 2 that you can create a Spaces volume and increase the overall availability by using a mirror or parity on your volume. Why use one or the other? In a nutshell, mirroring provides the best resiliency as it copies data twice or thrice on separate disks. This increases the cost per gigabyte, obviously, but it also provides the best performance when a disk fails. Parity provides a cost-effective solution to increase the overall availability of storage. It does, however, partially or even severely impact performance of disk writes. I personally only recommend parity or equivalent RAID 5 or 6 only when workloads are not write intensive like many databases. If you don't know the disk behavior of your app, skip parity and go to mirroring. You will not regret it. So a disk has failed, but you did an awesome job planning for this. You set up Spaces with parity, your VMs didn't skip a beat. With parity, there is a performance degradation though. What can you do to mitigate this performance degradation? Well, you can move the VM disks to a healthy volume while the VM is running, and that is storage live migration. Storage live migration moves live copies of the VHD files of a VM from one volume to another. This is an online move, so the VM does not have to be powered off for this to take place. A typical use case for this is when a drive in a volume fails. You would then use the storage live migration to move the VM to a healthy volume while the original volume is rebuilding. In the slide here, the VHD01 volume was impacted and we used storage live migration to move the disk to the new volume. Let me quickly demonstrate storage live migration here. So I have the failover cluster manager, see a number of VMs here, and I want to move this VM's disk. So I go to the settings of the VM just to show you where the disks are. Right now they are on the E/VM, and you see VM is running, so I'm going to be able to do this while the VM is running. I click on Move, Virtual Machine Storage, and in my case I will specify SMB file share on a scale-out file server. There it is, and you simply just drag the VHDs. You'll see here I have the VHD file, and I will go ahead and move the configuration and I click Start. Notice it starts saying starting virtual machine migration, and that's it. It's done. In this case, this is a small virtual disk. If I go back to settings, you'll see now it's pointing to that scale out file server share. And this was storage live migration. So a few important concepts in this lesson. First, drive failures are very likely and you should plan for it by using hardware radar spaces mirror or parity features. When a drive in a volume fails, you can use storage live migration to move the disks or a VM to a healthy volume without any interruption to the VM hosted on that volume. Next lesson focuses on Hyper-V Replica, one of my favorite Hyper-V features. In this lesson, I cover one of my favorite Hyper-V features, and that is Hyper-V Replica. 4 objectives in this lesson. First, I introduce Hyper-V Replica. I then tell you when to use it and how it differs from other replication features like Storage Replica. And we finish the lesson by going over some of the planning features and deployment requirements for clustered environments. So what is Hyper-V Replica? Recall, we covered Storage Replica in section number 2, where we can replicate entire storage volumes between locations as part of our overall business continuity plan. Where Storage Replica doesn't really care about the underlying application, Hyper-V Replica is specific to replicating Hyper-V VMs. It is extremely easy to set up and use, and unlike Storage Replica, it is available and fully featured in all Windows Server SKUs. Hyper-V Replica is an async replication technology. So technically, this is not an HA feature, but a DR or business continuity feature. It works just fine with high latency links like DSL links as long as the link speed can support the replication changes. Replica allows for the first or bulk initial replication to be an offline operation, so basically you'd copy the initial VMs to a portable drive, ship it, copy it back at the destination before you trigger the network replication. Replica is also supported for Hyper-V clusters over the same WAN connectivity. In fact, you can even use Replica between clustered and standalone Hyper-V hosts. So why Replica? Hyper-V Replica can be used as part of your business continuity strategy to provide continuous availability to your Hyper-V VMs in the case of planned or unplanned outages. Hyper-V Replica is not a replacement for backups, clustering, or Storage Replica for that matter. A specific use case is to provide availability for your VMs in the case of an outage. Replica has built-in support for test failover between sites, something you want to use whenever you do a DR exercise, for instance. Like every other feature I've discussed so far, planning is your key to success. Luckily, planning for Replica is pretty straightforward. You need to determine which VMs will need to be replicated. Typically, there is rarely a requirement to have all your VMs replicated from one site to another, as not all VMs have the same level of criticality from a business point of view. Replica can keep up to 24 hours worth of recovery points. If you are only replicating once a day, then you may lose up to a day's worth of data in the case of a failover. You can reduce this obviously by having increased replication schedule. Microsoft used to have a planner for Replica, although it hasn't been updated in a while. It's still a decent guide to help you plan for the overall capacity needed to replicate your most precious VMs. Where Hyper-V Replica is designed for purely an on-premises environment, Azure Site Recovery, or ASR, can replicate VMs from one data center to another, or from an on-premises data center hosting Hyper-V or VMware VMs to Azure. I mention it here for 2 reasons. First, it uses Hyper-V Replica to replicate to Azure. Second, because Hyper-V Replica does not provide native orchestration and modern planning tools, ASR does. For small environments, Hyper-V Replica alone is fine, but you will quickly appreciate ASR's ease of use in orchestrating multiple VMs and how it can group them together. In this video, I'll quickly configure Hyper-V Replica in a clustered environment. So I have Failover Cluster Manager open. What we need to do is create a Hyper-V Replica role. So I go to configure role. You see here there's a Hyper-V Replica broker. Click next. Notice some of the requirements here. So I give it a name. Again, this is a computer name in Active Directory, so make sure you have permissions on this container. Give it an IP address and next. follow the wizard to confirm. It's telling me where it's storing it in which container. And there you go. Finish. And you will notice that it has started this clustered role. So it means that this cluster is now ready for Hyper-V Replica. Very quick lesson. Hyper-V Replica is a very cost-effective solution for your VM replication requirements. Use Azure Site Recovery when you're replicating and you need that extra level of orchestration between the two sites. Otherwise, just the Hyper-V Replica native tools will be sufficient for small size environments. Next lesson is about memory management and how managing memory is critical for your overall availability of the Hyper-V environment. This lesson will focus on memory management. One feature we discuss is dynamic memory, which is Hyper-V specific. It has nothing to do like dynamic memory from earlier versions of Windows on DOS. I also discuss the sometimes controversial topic of page files and how to configure it from optimal performance for Hyper-V and the guest VMs. Dynamic memory. Dynamic memory is a feature enabled by the integration services. Integration services are a set of virtual drivers supported by the guest operating system. Dynamic memory is a set of values provided to and managed by Hyper-V to maintain the availability and performance of your VM. It is easy to use and configure, as you'll see shortly. It is a decision you need to make when you create a VM, although it's configurable after the fact as well. Not all guest VM workloads support dynamic memory. Applications which manage their memory independently of the operating system, such as databases, do not support dynamic memory. To configure dynamic memory, open the settings of a VM and go to the memory configuration. First, we specify the startup memory. This is the amount of memory Hyper-V will assign to the VM upon startup. This is the static value if you're not using dynamic memory. Next, specify the minimum and maximum value for the memory. Hyper-V will ensure that the VM does not use any lower value than the min RAM value and any more than what's specified in the max RAM value. Please make sure to configure both when you enable dynamic memory for a VM to ensure the performance and availability of the VM. Next, you can choose to change the value of the buffer. The buffer is a percentage used by Hyper-V to increase or decrease memory. It's a way to ensure the memory configuration remains somewhat close to a steady state and doesn't change frequently. Again, this ensures the Hyper-V host isn't just busy managing memory all the time, and when it does it in an effective and efficient manner. This may be obvious if you've worked with clusters before, but make sure to size the cluster with enough memory capacity. Even though many Windows Server admins have worked with clustering, not many have experienced active clusters where all nodes participate in the workloads. It is even more crucial with a Hyper-V cluster to size it correctly. Let me illustrate. Imagine this scenario with 4 Hyper-V node cluster. Each node is at 80% memory capacity. One host needs to be rebooted as part of a planned maintenance. I'm not even talking about unplanned outages, just the planned monthly Patch Tuesday maintenance. That node needs to be rebooted and the VMs distributed over the other nodes. Since each host is already at 80%, do the math and realize just isn't enough memory to handle the planned outage. In this scenario, you should have at least 5 nodes in the cluster. What happens when you don't have enough memory? Hyper-V relies on the memory weight to figure out which VMs should be up and which ones shouldn't be. Dynamic memory is fantastic. When should you not use it? Basically, 2 cases. When the guest OS doesn't support it. This used to be the case with some Linux distributions, but not really the case anymore. Although if you have older versions of Linux, it may still not be supported. Second, when the application doesn't support it or it manages the memory by itself, such as the case with SQL Server. You may be wondering at this point, okay, dynamic memory seems pretty straightforward to set up, but how does it actually work? Or how do I know that it is working? So let's do a quick demo. In this demo, I have a Hyper-V server here with a bunch of VMs, Hyper-V Manager, and I have some VMs configured for dynamic memory. Let me pick this Windows Server 2019 VM and show you the settings for dynamic memory. So notice I have minimum and maximum RAM to about 4 gigs and 8 gigs respectively. So I will go ahead and shut down this VM because the type of dynamic memory configuration that I need to do right now requires me to shut down. And I will lower the minimum RAM and keep the startup RAM to 4 gigs, but I will lower the minimum RAM to, let's say, 2 gigs of memory. What this means is that VM will be powered on, Hyper-V will allocate 4 gigs of memory. The lowest it will go is 2 gigs of memory. That's a way to guarantee. I will go ahead and start it. That's a way to guarantee that that VM will never go below 2 gigabytes of utilization. Notice it's using right now 4 gigs of memory. What will happen is after Hyper-V has started a VM, in a few seconds, it will realize that it doesn't actually need 4 gigs of memory, even though this is the startup memory that I configured it as, and it will start lowering the assigned memory for that particular VM. It actually happens pretty quickly, so let's just wait a few seconds. So keep an eye on the assigned memory value for that last VM. Notice, there you go, 2 gigs of memory, about a minute into it. You'll look at the uptime, 1 minute and 3 seconds. So about a minute into it, Hyper-V realized, oh, this doesn't need more than 2 gigs of memory, so I will give it 2 gigs. And that's how you know that dynamic memory for that VM is working. Next, let's have a look at what to do with the pagefile.sys. You may be tired of hearing me say this, but leave the page file settings to the default behavior for Hyper-V and the guest VMs. This allows for optimal size for the page file. Only thing I would consider doing is placing it on another VHD disk, and again, only if you're replicating this disk with Hyper-V Replica, since you don't really need to sync it. Memory management is simple in Hyper-V and guest VMs. Use dynamic memory when you can. Don't use it for apps that manage its own memory. Next, we have the final lesson about VMs and network availability. VMs and network availability. 3 features to discuss in this lesson. First, live migration. That's the network-based live migration, not the storage live migration. Clustering, as it's the critical feature enabling Hyper-V high availability. Finally, cluster-aware updating, which is a high availability feature allowing you to operate your environment while maintaining HA. Live migration provides VM mobility by allowing you to move virtual machines from one Hyper-V host or cluster to another over the network while the VM is running. It does this by copying data over one or multiple network links available between the 2 Hyper-V hosts. Recall we discussed the network configuration for live migration in the first section. It is very simply configured on the host by enabling incoming and outgoing migration. Clustering is the key HA feature of Windows Server leveraged by Hyper-V. If you've used failover clustering before, you know the HA is provided as a clustered role. With Hyper-V, each virtual machine is a separate cluster role, and each VM has its own priority. As you can see from this slide, each VM shows up as a separate role, and each VM has a priority. Consider putting your domain controllers or high priority VMs as high priority VMs so they get started first whenever the cluster is brought online. Cluster aware updating is another favorite feature of mine. This feature is awesome. If you've ever had to administer a Windows server at night or on a weekend, you'll understand why. Cluster aware updating does 2 things really. It manages and orchestrates the updating and patching of a Windows cluster. It does everything online, so you can do this during business hours if you want, causing 0 interruption to the users and the virtual machines. So how does it do it? First, cluster-aware updating will drain the virtual machines of a Hyper-V host. It does this one Hyper-V host at a time. Next, performs the maintenance and the updating and the patching of that Hyper-V host, and it restarts it and validates the health of that Hyper-V host before moving on to the next servers. Once that host is brought online and is determined to be healthy by cluster-aware updating, the VMs are brought back to that host or drained from the other Hyper-V hosts. Next, cluster-aware updating will move to the next Hyper-V host, does the same thing, drains the VMs, patches it, restarts it, and so on. High availability with Hyper-V is mostly provided by failover clustering. Just like any other cluster with Windows Server and failover clustering, each VM is a clustered role, and each VM could have a priority. The next session will be about the scalability and the multi-host management of your Hyper-V environment. In this fourth section, we shift from planning and deployment to operations. This section has 3 lessons. The first lesson in this section is an overview of your options for managing Hyper-V. There are a lot of options here, so I'll give you a summary of all your options. The 2 remaining lessons in this section focus around the 2 common and feature-rich options. These are the Windows Admin Center and System Center. First, an overview of the Hyper-V management tools. We focus on 3 topics. They are virtualization management, and virtualization management focuses on the virtual machine and Fabric Lifecycle tools, which allow you to create, modify, delete virtual machines, as well as general virtualization fabric functions. Monitoring is, well, as the name implies, about monitoring the virtual machines and the virtualization fabric. It helps make sure everything is running smoothly and generate alerts when things are misbehaving. Last, backups. Backups is about backing up your Hyper-V environment and the underlying virtual machines. Before we go into Hyper-V management tools, let me first begin by saying this. There are many tools. Each tool is very unique, and depending on how you have Hyper-V deployed, you may use a different tool or a specific capability within a given tool. For instance, if you have Hyper-V in a hyper-converged environment, you may use a different tool than if you are using a traditional SAN. With each tool, however, recommended approach is to manage Hyper-V and the virtual machines remotely. This makes your overall management experience a lot easier, not to mention more secure. Actually, in some cases, this may in fact be a requirement from your security department. Let's begin with virtualization management. So, what is virtualization management anyway? Virtualization management allows you to manage the entire lifecycle of your virtual machines as well as your Hyper-V environment. For instance, this is where you can create a virtual machine, manage the VM, modify the settings, and even delete it. This is where you can also provide access to a given user to administer that specific virtual machine. You have 4 options here. You can just use PowerShell. Hyper-V has an extensive number of PowerShell commandlets that you can use to fully manage your environment. Chances are you will use them with commandlets from Failover Cluster Manager if you are installing Hyper-V in a cluster. Next, System Center Virtual Machine Manager, or SCVMM. This is a licensed product and a full-featured virtualization fabric management product. It requires SQL Server Standard or Enterprise for deployment and can be deployed as a standalone or a cluster. I cover it later in this section with its own lesson. Next, Failover Cluster Manager. Failover Cluster Manager is an MMC-based user interface, so it's been around for a very long time. It is available as a feature in Windows Server or as part of RSAT, or remote server administration tools that can be installed on Windows 10 or another Windows Server 2019. Finally, the Windows Admin Center, codenamed Honolulu, is a modern server management for all your Windows Server services. This is especially important for hybrid management or hyper-converged infrastructure deployments. Once my Hyper-V environment is deployed and I have a bunch of VMs deployed, what do I do to make sure that everything stays healthy? How do I know when something is not healthy? How do I get alerts? That is the purpose of the monitoring and alerting tools, and just like with virtualization management, a number of options here. The first is a System Center product again. In this case, it is Operations Manager, or SCOM. This is a full-featured monitoring product, not just for servers or Hyper-V or VMs, as it monitors other things like network and storage and other devices or services you may have in your environment. Just like Virtual Machine Manager, it requires SQL Server Standard or Enterprise. It is a separately licensed product. SCOM is typically agent-based, where SCOM agent installation is needed on the Hyper-V and guest VMs. Azure Security Center and Azure Monitor are both managed services from Microsoft Azure that provide you a number of monitoring and alerting features. Azure Security Center, as you may guess from the name, focuses on the overall security health of your environment, and Azure Monitor pretty much monitors everything else. These are still licensed components and require an Azure subscription and install agents on these virtual machines, similar to how SCOM does it as well. Backups. There are a number of ways you can back up either Hyper-V or the VMs running on Hyper-V. These are called host-based versus guest backups. There are 3 options available. Data Protection Manager is another System Center component and is a full-featured backup product and has a number of interesting features like support for data deduplication. Yet again, you have to procure a license for it, and it requires SQL Server as its backend database. Windows Server Backup is built into Windows Server, and you can use it to back up Hyper-V and guest VMs. This is typically the installation option for a standalone Hyper-V host and not for large installations. Finally, you can use Azure Backup or Backup Server. These are full-featured cloud-based backup services to manage backups and still require an Azure subscription, just like we saw with the monitoring in the previous slide. So why would you use a cloud service to do operations and monitoring of your environment? For starters, these services are feature-rich and require no upfront cost, as is the case for System Center. System Center is a full-featured product that it requires significant expertise to deploy, manage, and operate. System Center also has very limited support for HCI deployments. Cloud services do not, however, provide capabilities to manage actual VM deployments or the lifecycle of these VMs. So you would still need something like Windows Admin Center or System Center Virtual Machine Manager for these. One of the best use cases for cloud services is for remote or branch offices where you may not have good network connectivity for something like System Center to work well. You will soon notice, and probably figured it out by now because you're just that smart, that one tool doesn't do everything for every scenario, and for large deployments, a number of tools is how you'll end up managing that environment. You may be wondering at this point, well, how do I decide which tool to use? That is a very good question. System Center is the most complete management suite for your on-premises environment. It does provide some hybrid capabilities, and you'll probably want to integrate some System Center with some Azure services such as backup or monitoring. Windows Admin Center is the new kid on the block. It has very, very active development. It already has a number of third-party integration components from vendors such as Lenovo, Riverbed, Dataon, and HP. It promises to provide you with a single management interface that system administrators just love. If you've seen demos for Windows Admin Center, you can see the potential is there already, and you will only get better with time. Windows Admin Center is, however, best suited for hybrid deployments where you have some Azure footprint and some on-premises footprint. It can be used to manage every single service of your Windows Server environment and not just Hyper-V. It does not, however, provide some of the deep templating capabilities of something like Virtual Machine Manager. Hopefully you're not confused by all the management options. Each option has a set of PowerShell commandlets, so I guess in that sense, PowerShell is a common platform for managing all the virtual machines and your Hyper-V environment. Just please do manage those servers remotely and do not install the management tools on the servers themselves. In the next lesson, I cover System Center in more detail. In this lesson, I introduce you to System Center. So in this lesson, I will begin by introducing System Center and then go into more details of Virtual Machine Manager and how you can use it to manage Hyper-V. I walk you briefly through planning and the deployment aspects of Virtual Machine Manager. Please note that System Center Virtual Machine Manager 2019 was not yet released at the time of this writing, so I based the information on the current VMM version. That said, everything you see here should be applicable to 2019. System Center is Microsoft's data center management product. It has 8 components, each managing a specific component of your data center. Everything from configuration management to operations management, service management, automation, and the one most relevant to us perhaps is virtual machine management. We will cover Windows Admin Center in the next lesson. For now, you can consider Windows Admin Center as the hybrid server management tool. So what can you do with System Center? It may be easier to say what can't you do actually. System Center is a full-featured and very mature product. Some of the components in this suite have roots which are over 20 years old. System Center can be used to manage the entire lifecycle of a server or virtual machine. Everything from deployment, updating the virtual machine or server, application lifecycle management on that VM or server, to monitoring the health of that server, automating workflows and operational processes such as service management workflows. All this while providing self-service capabilities and protecting the overall availability and security of the servers. I did say maybe easier to say what can't you do with System Center. HCI is probably the key gap, although Microsoft does provide support for HCI features like Storage Spaces Direct within Virtual Machine Manager, for instance. This is an area where Windows Admin Center may be a better fit. Microsoft has made a lot of progress in the past 3 years integrating some of Azure services within System Center, such as Azure Backups and Azure Site Recovery. You can see Windows Admin Center already providing richer capabilities here, for instance. Some of these gaps can be overcome by Windows Admin Center, which is a free download, as well as with the Azure portal, which requires an Azure subscription. So let's now focus on Virtual Machine Manager, or VMM. VMM focuses on the software-defined infrastructure. So, the software-defined networking, software-defined storage, and keep in mind that with Windows Server 2019, the recommended approach to deliver software-defined networking and multi-tenancy is SDN Express. If you are going to use Virtual Machine Manager with Hyper-V, it would be for the extensive and powerful templating capabilities and automated IP address management. These two features alone are worth the cost and effort of deploying VMM, in my opinion. I demonstrate both of these in this lesson. VMM is not just about virtualization though, and it can be used to deploy a private cloud, although this is less common today as public cloud services have become much more prevalent. VMM is unlike any other virtualization and data center management tool you may have used. It is awesome, and not to mention very cost-effective compared to competing products. So think of the entire virtualization management lifecycle. First, you would need to have some Hyper-V servers where you will eventually store some VMs. VMM can help you deploy these servers from bare metal. Second, you may want these Hyper-V hosts to be clustered or provide a shape to your VMs. VMM can help you create that cluster and manage it. Once you've had those clusters up, can VMM help you deploy VMs from pre-configured and standard templates? It sure can. What about self-service? If I want to give each VM or app owner console and full access to their VMs to start them, shut them down, maintain them, well, VMM has self-service roles built in and can help with that as well. DR or disaster recovery is very important for your business, and we talked about Hyper-V Replica. VMM can help you manage your application between your data centers with the assistance of Azure Site Recovery. VMM can also provision software-defined networking and storage for you. VMM is also the best tool to orchestrate Hyper-V cluster updates with cluster-aware updating. That's not all, of course, but these are the highlights and some of the most common and popular features of Virtual Machine Manager. So what do you need to deploy Virtual Machine Manager? To plan a Virtual Machine Manager deployment, let me begin by illustrating the different components of VMM. First, we have our Hyper-V clusters, which may or may not have been deployed through VMM. These Hyper-V servers are managed by VMM's management servers. When you add a Hyper-V server to VMM, it installs an agent, which is used then to keep that connection with a specific VMM server or cluster. VMM stores its configuration into a SQL Server database. This could be a clustered SQL Server installation. VMM also stores details such as virtual machine images onto a library server, which is essentially just a Windows file server serving a standard file share. This file share is managed by VMM. When it's time to apply patches, VMM coordinates the update management using cluster-aware updating, and updates are applied from the WSUS server. VMM continuously manages and orchestrates the components of this environment. Everything is managed remotely, of course, from the VMM console installed on an admin's PC or laptop. You can also deploy the VMM management library in SQL Server on a standalone server. This is fine for smaller environments, but as you can imagine, it doesn't scale very well. What do you need to figure out for the VMM deployment? First, whether you want to do a distributed or standalone deployment. Most deployments serving tens or hundreds of Hyper-V hosts will be distributed through Scale. Second, is it a single host or clustered VMM deployment? Both VMM and SQL support clustered installs. This one is really a matter of preference. I always prefer a clustered deployment as VMM is typically critical for the management of the virtualization environment. Keep in mind that VMM only supports active standby deployment, so the main benefit is increased uptime. Similarly for SQL Standard versus Enterprise. With Enterprise, you can have an active SQL deployment. If you are managing Hyper-V hosts in multiple data centers, you will want one library server per data center. VMM has built-in roles for VMM admins and self-service users, so you will need to decide who will manage VMM and which users will have access to their own VMs for self-service. Finally, networking. VMM can manage the IP address assignment of all your VMs and Hyper-V hosts, so you can simply carve up a segment in your network and have VMM manage it. This is just a summary. Have a look at the detailed guide at the link shown here. To deploy VMM, you need at least one Windows Server 2012 R2 or higher, obviously with the recommendation to go to 2016 or 2019 for the management server, with SQL Server 2012 or higher. And you need a couple of extra utilities like the SQL Server command line utilities and the Windows ADK. ADK is actually needed for the bare metal provisioning of Hyper-V hosts. So even if you don't want to use that feature, you still need the Windows ADK. The VMM installer will warn you when it's not available. Let me walk you through an SCVMM deployment. First, we'll download and deploy the ADK, run the setup. Basically, you choose default installation parameters with one exception, and that's just the specific components of the ADK, but otherwise it's a default installation, accepted license agreement. This is where you select the specific components. There's a bunch of them. The only ones that really are needed by VMM are Windows PE and the deployment tools. So you can uncheck all the other stuff to save on space, and you just click install with these two items selected. Installation goes by rather quickly at this point. Close when it's done. Notice it says Windows 10, but don't worry about that because the same ADK is used to deploy Windows 10 images as well. And that's it. Next, we'll go and download the Windows SQL Server 2016 feature pack. That's the version I'm installing here, but you can use 2017. When you click on download, you'll see there's a bunch of components. There's really two that you need. The ODBC MSI, so these are the database drivers that VMM needs to connect to SQL Server, and the SQL command line utilities MSI. That's it. These are the two components that VMM needs. Click on next. First, have to install the ODBC, follow the default installation, accept the license agreement. Next. You don't need the SDK. Very quick install. Then we can go ahead and install the SQL command line utilities. Next. Accept the license, pretty standard stuff, very, very lightweight components. With that in mind, we are ready to deploy SQL. In my case, I will just do a standalone SQL, not a clustered one. So run the setup. Let's minimize that, get out of the way. I go in installation, new SQL Server standalone. In my case, I'm installing everything SQL library, everything on the same machine. This is for demonstration purposes. So the SQL Server installation is pretty standard. I'm installing a single instance. I will always run Microsoft Update if your server is connected to the internet to download the latest updates. It does warn me about the Windows Firewall. I always have the Windows Firewall on. It's telling me that I need to enable a firewall rule for SQL. That's not an issue because VMM and SQL are on the same machine. Really, the only component that VMM needs is the database engine for SQL. I don't need any of all that extra stuff that SQL Server provides. So I'll just go ahead and check the database engine services. Click next. Default instance or a named instance, it doesn't matter. VMM supports both. I'll just go ahead and select default instance. Again, this is just for showcasing all the different components that are needed for the installation and actual production deployment. I will go ahead and accept an NT service account for SQL Server Agent and Engine. In clustered environments, you're going to need a domain account, obviously, but we're not using a clustered environment here. I will go ahead and select mixed mode. You can do Windows authentication mode as well. Most DBAs I know like to have mixed mode. I'll enter a password and I'll add SQL Server administrators. So I have a domain account with SQL DBAs. So I will go ahead and add that. There we are. Next. SQL is finished installing. It's telling me the installation was successful. Let's close that and let's do VMM installation. So I have the VMM media. I'll run the setup from the VMM media. Again, this is not 2019, but this is version 18.01 as you see here. The process hasn't changed really for VMM in a few releases now, so 2019 should be the same. You click on the installation. It launches the installer. I want management server on a console. Next, now if you had failover clustering installed, VMM installer will detect that and it will tell you that it wants to install VMM as a cluster. I'm not going to supply a product key here because this is just an evaluation. Accept license agreement, diagnostics and usage data to send to Microsoft for analysis so that they know which features of VMM are you using. It's on by default, but you can turn it off. Installation location, I'll accept the default. Now it's asking me where the database is. In my case, it's on my VMM server. If you had it remotely, you can type in the server name. This is a default database name that VMM installs, Virtual Manager DB. I supply it with the database connectivity parameters, in my case, my administrator account. Here, it's asking me about distributed key management. That's only needed if you have a clustered environment where VMM can save encryption keys in Active Directory. Next, it lists all the port information used by VMM. Next, it gives me the chance to create a library share. Again, I'm doing everything on the same server. It's just pointing it to a different location on my server. This is a default name, share name that it gives me. I'm going to go ahead and put it on a E drive for me and click next. And that's it. I click install. It starts the installation. Once it's finished, you'll see the green check marks and you have the option of checking for updates and opening the VMM console, which is right there on the desktop. And that's it. You have VMM deployed. Keep in mind that for larger Hyper-V deployments, yes, I think you should deploy VMM. I think there's a lot of benefit for it. Smaller or branch type deployments, you will see that Windows Admin Center is sufficient. Next, we will have a look at the Windows Admin Center. This lesson will go through the Windows Admin Center. This lesson, we cover three objectives. I first provide you with an overview of the Windows Admin Center, and then I will walk you through the planning and deployment of the Windows Admin Center and the different options available for you in terms of deployment. First thing I want to mention about the Windows Admin Center is that it's specifically designed for hybrid environments. Windows Admin Center is a modern platform for server and hardware management. It's a simple download and accessible through a modern browser interface. It provides centralized management to your on-premises servers as well as connectivity to some hybrid services in Azure for doing things like backups and updating your servers with Azure Update Management. One of the really cool things Microsoft did with the Windows Admin Center is provide SDKs or software development kits to third parties so that they can integrate their management capabilities and provide the administrators of a single management interface. Two final points come up with Admin Center is that it has a very active development and you will continue to see updates and features and capabilities integrated into Windows Admin Center. Not just from Microsoft, but from other vendors such as hardware management vendors and network vendors who will integrate it into the Windows Admin Center. Finally, and this is me saving the best for the last, it is a completely free download. You just download Windows Admin Center and install it in your environment to manage your servers. Here's a screenshot of the Windows Admin Center. Notice you have capabilities to manage the server and do things like shut down and restart. On the left pane, you have all the Windows Server features that you can manage with Windows Admin Center. And at the bottom, you have some pretty cool monitoring and dashboarding capabilities. Let's talk about how you plan for deploying Windows Admin Center in your environment. There are 4 deployment options. They are based on the size of your managed environment. How many servers do you want managed by Windows Admin Center? And if you have a very small environment, for instance, or a branch office, you can simply do a small scale deployment on a Windows 10 PC. For medium-sized or distributed scenarios, you can actually install Windows Admin Center on one of the managed servers. I'll explain what that is in a few minutes. This is not a deployment scenario that I would recommend. As I mentioned in the first lesson in this section, I highly recommend you manage servers remotely, and in fact, this may be required by your organization. For larger scale deployments, you can do one of 2 things, either dedicate a VM or PC or even a VM in Azure for Windows Admin Center, or deploy it on a cluster to manage larger scale environments. Let's have a look at every one of those options in more detail. The first one is to install the Windows Admin Center on a Windows 10 PC. That Windows 10 PC will then connect to the managed servers through PowerShell and WMI. Again, this is suitable for maybe dev test environments or a very small branch office, not typically something you would see or recommend for a larger number of managed server deployments. The next deployment option is to deploy Windows Admin Center on one of the managed servers. Again, not a recommended setup. You should really deploy it and manage all these servers remotely, but this is a supported scenario. In this scenario, once Windows Admin Center is deployed, it is accessible from a web browser over HTTPS. Our third and fourth scenarios are very similar in that you install Windows Admin Center on a standalone server or VM. And by the way, this does not have to be an on-premises VM. It could be a VM in Azure, as I mentioned before, or even a physical machine. Not that you would be doing that because, well, this is a Hyper-V course and we're virtualizing everything, right? You would still use a web browser from a remote machine to connect to the Windows Admin Center through HTTPS, and the Windows Admin Center server would then connect to the managed servers through PowerShell or WMI. You're probably seeing a pattern by now. The final option is exactly like the one we just saw, except instead of one Windows Admin Center server, you have a cluster. The client or the administrator will access this cluster via HTTPS through the cluster interface. As part of the planning, you have to plan 2 types of access roles. The first is the gateway user. This user role provides access to connect to the Windows Admin Center gateway. Once connected to the gateway, this user can then access the resources for which they have permission. The other role is the gateway administrator. Gateway administrator has all the privileges of a user, except they can create and manage user accounts. Granting access to the gateway does not provide access to the managed servers. When a gateway user or administrator logs on to the gateway, they still need to have access to the individual managed servers to perform any type of administrative function. Finally, the Windows Admin Center supports Azure Active Directory, and this is required in scenarios where you are integrating Windows Admin Center with services like Azure Backup and Azure Update Management. To deploy Windows Admin Center, you need to download the installer at the link I provide here and run the installer. 2 things to do here. First, you make sure it has the Windows Management Framework or WMF 5.1 or higher. This is really required for older versions of Windows Server. This would not be required, for instance, if your managed servers are Windows Server 2019. Next, configure access roles. You would need local admin privileges on the managed servers so that they can be reached and managed via the Windows Admin Center. Let me walk you through the process of deploying Windows Admin Center in a local or gateway type installation. I've gone ahead and downloaded the Windows Admin Center. I have it here on my desktop. I'll go ahead and run the installation. You'll see it's very straightforward. I'll accept the terms. Next, it's telling me that it will install the gateway server installation. Allow Admin Center to modify the trusted host setting. I can choose to have it on HTTPS. This is where I can provide a self-signed certificate or not. Run UAC, accept it. It goes ahead, deploys the configuration. In my case, I also configured it. You saw that checkbox where it says redirect HTTP to HTTPS, and that's it. I'll click finish. I'll go ahead and connect to it from Windows 10 machine that I have. I type in the URL, the HTTPS. I'm using self-signed certificates, so Edge is telling me that it does not trust the certificate, but that's okay because I do trust the server. This is my installation. I'm getting credentials to log in to my server. I can choose to say remember. Again, the access control is different from the management servers to the gateway. There's a nice little tour you can start. I'm going to go ahead and skip that. So this is my gateway server. I'll click on it, and this is everything that I can manage on it. So there's files, there's firewalls, and this happens to be a Hyper-V host. So I have virtual machines on it as well. Notice it gives me already some options to do Azure Site Recovery for integration with Azure, giving me some metrics about my Hyper-V host. Really, really interesting stuff. And now you have deployed the Windows Admin Center. I've only begun to scratch the surface with the Windows Admin Center. It is a feature-rich product, and I could do a course just on the Windows Admin Center. Go ahead, download it, try it, explore the capabilities, especially if you are considering hybrid or HCI scenarios to integrate with your Azure Update Management, Azure Backups, Site Recovery, all these types of services. It can significantly reduce the management overhead by providing a single interface for managing the servers like the hardware and the key operational tasks such as backups and patches or updates. This is the end of section 4. In the next section, we go a little bit deeper and focus on Linux and look at what it takes to run Linux on Hyper-V. In this 5th section, we cover Linux and FreeBSD support on Hyper-V. This section has 3 videos. Heterogeneous integration is the first one, where we discuss just how Microsoft provides Linux and BSD support on Hyper-V. We then have 2 sections focused on Linux deployment and management. Heterogeneous integration is the first one, where we discuss just how Microsoft provides Linux and BSD support on Hyper-V. We cover 3 topics. LIS, or the Linux Integration Services, is the set of tools Microsoft developed to include Linux support on Hyper-V. Linux on Hyper-V showcases the state of Linux support on Hyper-V. And finally, in this lesson, and it has been a common pattern throughout this course, we detail some very specific planning points around Linux. So what are those Linux integration services? Linux Integration Services, or LIS for short, as well as the BSD Integration Services, or BIS for short, are a set of drivers, tools, and services Microsoft has developed and released to the respective Linux and BSD communities in order to provide support for Linux and BSD on Hyper-V. When Microsoft releases the source code of these tools to the community, the tools are then integrated into the kernel. From there, any Linux distribution or BSD distribution can choose to enable these drivers. LIS and BSD provide primarily virtual device drivers to Linux and BSD, so things like virtual NICs, virtual storage adapters, etc. What's fantastic about this approach is this: any Linux distribution that decides to keep the default behavior enabling support for Hyper-V through LIS automatically has support for Hyper-V. This has been the way to enable Linux support for Hyper-V for a while now, but there are some older Linux and BSD distributions for which you will need to enable and install LIS or BIS separately. We'll discuss how to go about this shortly. The thing to keep in mind is this: just like with Windows Server or guest VMs, not all Linux VMs support all features of LIS. I list a number of features here in the slide, but it is important to validate feature compatibility from the link I provide here. This lesson is focused on Linux and LIS. That said, LIS concepts typically apply to the FreeBSD integration services. Whenever I speak to someone about Microsoft's Linux support, the discussion typically goes in one of 2 directions. Some folks who have been around the Linux camp for a while, by a while I mean 15 plus years, will probably say something like, Microsoft doesn't play nice with Linux. The other direction this goes, Microsoft has improved its working relationship with Linux community, but it's not as good as some of the major Linux vendors. Both can't be further from the truth. Microsoft has made a huge bet on Linux and open source in Hyper-V, and Azure, where over half of the VMs deployed are Linux. In fact, did you know that Microsoft has a Linux distribution called Azure Sphere OS? Microsoft's commitment to Linux is clearly demonstrated by their contribution to the Linux kernel, where they consistently rate in the top 5 or 10 contributors to the Linux kernel. And Microsoft also provides a wide range of support for Linux distributions from CentOS, Debian, Oracle, SUSE, Ubuntu, and Red Hat. For each Linux distribution, you will need to ensure that list is present and installed in order to have the best performance of your Linux VM. Most modern Linux distributions have the Hyper-V list bundled and enabled. Remember Hyper-V Server? We discussed it in the very first section as a great option for hosting Linux VMs and Windows client VMs. Just wanted to remind you, it's a great option for hosting Linux. You are welcome for the reminder. One final note, Microsoft publishes a guide on best practices for running Linux on Hyper-V. Have your Linux sysadmin review it in detail as they are mostly Linux-based tweaks. Now, what about the planning steps? The first thing you need to do is validate your distribution support. So validate if your Linux distribution is supported natively under Hyper-V. If it's not, you will need to go ahead and find the Linux integration services for Linux and download these. How do you find whether the Linux integration services are built in or supported? Well, you can go to the link provided here in Microsoft's documentation for Hyper-V support, and it shows you distributions of Linux with built-in list drivers so you don't have to do anything. Just notice in the documentation, Microsoft has yet to update this documentation with Windows Server 2019 as of the time of authoring this course. Next, once you've validated that your distribution is supported, validate if this specific feature you're looking for is actually supported in lists. As a general rule, most of the modern features are supported in the modern distributions of Linux. Older distributions of Linux, you will see there's a link to the list download site. That's where you go and get it and follow the instructions to install it in your specific Linux distribution. In this video, I'll show you how to go about the planning steps straight from the Microsoft website. So the first thing you want to do is go to the supported Linux and FreeBSD virtual machines for Hyper-V on Windows page. I have the link provided in the slides. Next, pick the specific distribution of Linux that you're looking for, or BSD. So let's have a look at CentOS and Red Hat, for instance. Then scroll down to the specific series for CentOS and Red Hat in this case. Notice the legend that says anything with a check mark built in. So that's where you go and check the version of Red Hat. Notice the different versions. And for a modern version, notice that there's two versions of 7.5. That's just confusion associated with how Red Hat went ahead and named its version of Linux. But it shows for modern ones, which ones are built in, the features on the left, which version of Hyper-V is supported under. And for ones that are not, well, you see this is the old 7.5. Click on Linux Integration Services from there, and you go ahead and download it. There's an ISO file that you can just mount, or the tar file that you install in Linux. And that's it. Hopefully you've seen that Microsoft treats Linux as a first-class citizen with very good support for Linux on Hyper-V. Modern Linux distributions have the Linux integration services built in to the Linux kernel. All you need is typically to just acquire that distribution and install it. We'll see that in the next section. For legacy Linux distributions, you will go ahead and download and install the Linux integration services. The next lesson will look at actually deploying Linux VMs on Hyper-V. Deployment of Linux VMs on Hyper-V. There are three objectives of this lesson. We first cover the requirements. What do you need to deploy Linux VMs? What are your options for deployment? And finally, we actually go through the process of deploying a Linux VM so you can see how it's done. Requirements. Requirements are actually very, very simple, especially if you have a Linux distribution that already has the Linux integration services. You really need to just download the ISO file of the Linux distribution. It's actually pretty straightforward. Remember, Linux is a first-class citizen of Hyper-V. So it's the same process as you would follow to install and deploy Windows Server. Hyper-V is awesome with Linux. Really, the only option you have is the same that you would have with Windows Server. Are you going to deploy it as a Generation 1 or Generation 2 VM? There is one tiny change that we'll cover if you are going to deploy your VM as a Gen 2 VM. But instead of me talking about it, let's actually watch it happen. In this demo, I will go ahead and deploy a Linux VM on my Hyper-V cluster. So the first thing I do is I open my failover cluster manager. They're all Windows VMs so far, but let's go ahead and create a new virtual machine. I will create it on my node, my Hyper-V node, and the new VM wizard starts. Same process as the Windows Server VMs. I'll give it a name, tell it where it's going to go, put everything under e/VMs in my case on this environment. Next, I will go ahead and pick generation 2 VMs because I wanted to show you afterwards some of the changes associated with that. Just like Windows, I can go ahead and enter memory configuration with dynamic memory. Most modern Linux kernels support that. Networking, configure my vSwitch. I'm just going to go ahead and accept the default for the virtual hard disk. Point it to the ISO file that I downloaded earlier for my Linux distribution. In my case, it's Ubuntu. And finish. So there it is. Let's configure some additional settings that are not available in the wizard. So the first one, make sure it's going to boot from the DVD. So that's my Ubuntu ISO file. Secure boot is enabled, but we will go ahead and change it to Microsoft UEFI Certificate Authority. That's a requirement for Linux. Make some changes with dynamic memory. I always like to specify minimum and max memory, and I'll just give this one an additional processor. Okay, go ahead and start it and connect to the Linux VM. Notice the Linux VM is booting. You don't have to worry about all of this. I'll just quickly go through the process to install Linux on this VM, choose the language, provide some networking information. I don't have a proxy server. Disk configuration, I will go ahead and use my entire disk for this and tell it to wipe everything, give it some username information. Again, this is a standard Linux distribution. This is not Hyper-V specific, so I'm just going to quickly do this to just show you that the process is identical as you would on a physical Linux server or any other virtualization platform. And I'll go ahead and start the installation. Once the installation is done, I can go ahead and log into the environment, my username and password, and I'll do an lsmod and grep HV to show you these are the Hyper-V Linux Integration Services modules. I didn't have to do anything. My Linux distribution came with them, and they got enabled the second the Linux installation got installed. So sometimes the best way to learn is by actually watching. That's what I tried to do in this particular video. Remember, Microsoft loves Linux. Linux plays a very key component on Hyper-V and Microsoft Azure. It is a first-class citizen. As you saw, the actual deployment, there's hardly any change between Linux and Windows Server deployments on Hyper-V, and I would encourage you to try it. The only difference is with Generation 2 VMs, you have to just configure the UEFI secure boot, and that's the only difference. In the final lesson of this section, we go through a number of tools available for managing Linux VMs. In this final lesson of this section, we cover the management of Linux VMs on Hyper-V. In the previous section, we looked at overall management of Hyper-V and Windows guest VMs. Are Linux VMs any different? We will cover this in the two objectives in this lesson. We first by providing an overview and then some Linux-specific recommendations on Hyper-V. An overview of Linux management. You probably wouldn't be surprised to know that most, if not all, of the management features from the previous sections apply to Linux. That is, you can manage Linux VMs with System Center, Windows Admin Console, Server Manager, Failover Cluster Manager, etc. Again, as in the case with Windows Server, you have to make sure that the features you need are supported with the management tool that you need. Next, we cover any recommended configuration items or best practices Microsoft publishes for running and managing Linux on Hyper-V. I did share this link with you in the previous lesson. Here's that link again. I want to go over some very specific items from that list of best practices that I think will touch most Linux deployments on Hyper-V. The first one is a dynamic VHDX tuning. This is a file system level configuration when you deploy the Linux VHDX file, which will have as a result the reduction of the amount of actual disk space used when you deploy Linux using a dynamic VHDX file. What you will have to do in cases where you're using a dynamic VHDX files for Linux is to use PowerShell with the new -vhd command and just make sure you add the -block size byte to something like 1 megabyte. This ensures efficient usage of actual disk space on the VHDX. The next recommendation is with respect to grub menu timeout. Grub is the Linux bootloader, and what happens with Generation 2 VMs is that they will boot too quickly that you will not actually witness that grub menu. So what do? Well, you need to change that timeout value in the Linux VM, speak to the Linux administrator, and just give them this information. There's a grub timeout in the grub configuration file. Increase it from something like 5 to 100,000, and then you'll be able to see that grub menu when your system boots. The next recommended practice would be to change the value of kdump. This is needed for troubleshooting purposes. Just like with Windows servers, Linux has the option to dump the contents of memory to disk in the case of a crash. This is accomplished using the crash dump utility. Do consult with the Linux system administrator and ask him or her to install the Linux crash dump package. Once the package has been installed, change the configuration to increase the memory from something like 128. In this lesson, we reviewed some of the recommended configuration items when using Linux on Hyper-V servers. Linux management is very similar to Windows Server management on Hyper-V, with the exception with a set of best practice configurations to optimize the overall performance of Linux VMs on Hyper-V. In the next section, we cover the operational task of upgrading cluster nodes and virtual machines. Section number 6, we will talk about upgrades, specifically upgrading cluster nodes and the virtual machines. This section has 3 lessons. We will start by talking about how to upgrade your virtual infrastructure, what's involved in that. Then we go and talk specifically about the cluster nodes. You'll see some pretty cool features in Windows Server 2019 there that helps you with that. And finally, what's involved when you upgrade your virtual machines. We will start by talking about how to upgrade your virtual infrastructure, what's involved in that. Windows Server upgrades, as with any infrastructure upgrade, has really 3 phases, and those are the ones that we'll focus on as objectives of this lesson. What to do before the upgrade, pre-upgrade, what to do during the upgrade, and what to do afterwards. Let's start with the pre-upgrade. First, there's some analysis that you have to do where you're starting from. We're talking about in-place upgrade paths. Now, a lot of Windows system administrators don't really like in-place upgrades, but there's a lot of benefits to that when you consider that you maintain your hardware. Windows Server 2019 has a very limited upgrade path from prior versions. If you've been around Windows Server for a long time, you know there's a very similar story here. Basically, if you are coming from Windows Server 2012 R2 or 2016, you have a direct upgrade path. Otherwise, you will have to do 1 or 2 upgrades before you get to Windows Server 2019. First step, the planning aspect. Now for Hyper-V, it is pretty straightforward. Planning involves moving the virtual machine somewhere else. If it's a standalone machine and you're doing an in-place upgrade, you'll need to maybe do a backup and restore. We'll talk a little about that in a few minutes. But bottom line, for planning for standalone Hyper-V host is no different than any other Windows Server host. So you have to do things like, when are you going to do it? Do you need a maintenance window? How critical is the server? Who's using the server, and what's running on the server. In your case, we're looking at Hyper-V, so which VMs are running on it and who are the application owners or the virtual machine owners that need to be advised. Additionally, you will want to make sure that your backups are happening on that Hyper-V host. If you are coming from Windows Server 2012 R2 or 2016, what were you deploying on the Hyper-V server? If you have any software-defined networking or software-defined storage, those are key elements to consider as part of the planning aspects. Not a lot more to talk about in terms of planning, so let's get to the upgrade. So failover clustering and VM upgrades, we'll cover these in the subsequent lessons in this section. But for In-place upgrades for Hyper-V, yes, it is possible, but as I mentioned, the only thing that you have to be aware of is where do you place the VMs during the upgrade process. That's where Shared Nothing Live Migration works really well. You can move it to another Hyper-V host and go ahead and do the upgrade process. Once you've actually gone through the upgrade process, then you log into the server, validate the event viewer, restore the VMs, and ask the users to log into the VMs to make sure that everything is healthy. It's a very short lesson. Essentially, Hyper-V in-place upgrades are possible. The only thing to keep in mind is for the virtual machines, move them to another Hyper-V host using something like Shared Nothing Live Migration, or back them up and put them on another host while you do the upgrade, and then you can move them back afterwards. The next lesson, we focus on clusters and how to go about upgrading cluster nodes. Some pretty cool features with Windows Server 2019. Let's have a look at that. In this lesson, we focus on the upgrade process of a Hyper-V cluster and its nodes. We will go over the options available to you, and then I will walk you through some of the coolest features of failover clustering, and that is the Cluster OS rolling upgrades. First, what are your options? We begin by going over the HCI upgrades. What do you do when you have an HCI setup? HCI, you need to do two things. Wait till your hardware is certified for Windows Server 2019, and then from there, you just follow the general upgrade approach discussed in the previous lesson. Chances are the HCI vendor will use a number of built-in features such as the cluster rolling upgrade we will see later in this lesson, with the addition of driver updates. So what are your options? You really have two options. You build a new cluster and move your VMs to it, or use the awesome new feature introduced in Windows Server 2016 called Cluster OS Rolling Upgrade, which allows you to have coexistence between two Windows Server OS versions in that same cluster. First option is really about a brand new deployment, and I think we've discussed this enough by now, and you are tired of me talking about planning and deployment. This lesson is about upgrades. I will discuss the second option. Here's the problem. How do I upgrade a Hyper-V cluster with tens or hundreds or thousands of VMs with minimum impact to the VMs? Microsoft has thought about this very carefully, and that's why they introduced with Windows Server 2016 and again in 2019 the Cluster OS Rolling Upgrade. Cluster OS Rolling Upgrade allows you to introduce a current Windows Server version in a cluster without breaking or upgrading all cluster nodes in one shot. If you are familiar with domain controller upgrades in AD and how they work, you will see some similarities here. OS Rolling Upgrade allows coexistence between two versions of Windows Server to facilitate the upgrade of cluster nodes. Microsoft did this to allow you to upgrade your Hyper-V clusters with zero downtime to your VMs. This is, however, not an excuse to run your cluster in mixed mode with two OS versions for extended periods of time. I would say do not run a cluster with two OS releases for more than a month. This feature is about upgrades. If upgrades are taking you longer than a month, you may be looking at a migration and not an upgrade. Highlights of this feature include the ability to mix two OS server releases, with the caveat here is it has to be N and N-1, so you cannot have a cluster with, let's say, 2012 R2 and 2019 nodes, for instance. This feature introduces the cluster functional level attribute. You'll see how this is used shortly. The cluster functional level is a way to describe the OS server version support of the cluster. By default, Windows Server 2016 clusters have a functional level of 9. As you upgrade one node to 20 Server 19, the functional level remains the same. It basically means that you can add Windows Server 2016 and 2019 cluster nodes to that existing cluster. While in this mode, you can only take advantage of 2016 clustering features. 2019 features are not supported yet in this functional level. Once all nodes have been upgraded, the cluster functional level remains the same. it basically allows you to do a rollback if needed. Once you have upgraded and happy with the cluster, you can increase the functional level to the latest release, meaning you can take advantage of all the latest and greatest features of failover clustering in Windows Server 2019. Let me show you how this works in this demo. Let's start by having a look at our Windows Server 2016 cluster. I have my PowerShell open. Let's do a get cluster, show you I have 2 nodes, 2 servers, both of them are up. Let's have a look at the functional level of this cluster. For 2016, remember, it should read 9. This is exactly the case here. Let's just go to failover clustering. I'll show you here. See, it's Windows Server 2016. The other node is Windows Server 2016. No magic. We'll go ahead and try and add a Windows Server 2019 server. The standard failover clustering add node wizard. I'll go ahead and supply the node name. Click add. That node is there. It has failover clustering on it. I will uncheck the available storage because that node in my case doesn't have any new storage to offer. And click next. This will add the node, and there you go. Finish. You see that node is added, and it's a Windows Server 2019 Data Center Edition. So remember, this is a mixed mode cluster. The functional level should remain the same. Let's validate that. It's still 9 as you can see here. So I'll go ahead and update the functional level. This is the same cluster, but only one node, which is 2019. I've gone ahead and evicted the 2 2016 nodes just to make it simpler for my demo. I'll demonstrate this to you by showing you this is still same functional level. It has not changed. Still the 2016 functional level, which is 9. As you can see here, it's just same cluster, one node, 2019. I've evicted the 2016 one, so only a 2019 cluster. I'll go ahead and create a cluster object in PowerShell, which is just get cluster. Then I will issue the update cluster functional level on that cluster object. It's asking me to confirm. Yes, I do want the update cluster functional level because this is a one-way street. Cannot roll back the functional level. It did it. So just to validate what the functional level is at this point, that the upgrade actually went through, and you see it is now a 10, what it is for 2019. And that's it. That's how you get your upgrade done. So how did you find that? Cluster OS rolling upgrade is a pretty neat feature. It allows you to update your Hyper-V or clustered environment for that matter with zero downtime to your clustered roles, such as your virtual machines. Very, very, very cool and awesome feature. Next, we look at the impact of upgrading virtual machines. Is there one? Let's have a look in the next lesson. In this lesson, we shift towards the guest VMs. So everything we've seen in this section really applies to guest VMs. There is one exception. That is the upgrading of integration services. Recall that integration services are a set of virtual device drivers. So really a single objective in this lesson. With prior versions of Windows Server, this section would have been much more involved. Luckily, Microsoft has done a lot of work to simplify and streamline the process associated with the Hyper-V host upgrade of the guest VMs integration services. So why would you consider upgrading integration services? Fundamental reason is to get new functionality. Every time Microsoft updates integration services, they can introduce new functionality as well as security updates. Microsoft has done a lot of work to make it easier to upgrade the integration services. In a nutshell, if you have an up-to-date version of your Windows OS or your Linux OS, then you have an up-to-date version of the Windows or Linux integration services. You get them from the Microsoft update. As long as your OS is up to date, then your integration services are up to date. You have the latest security features and you have the latest and greatest features of integration services. How do you check if you have latest version or what version you have? You can simply use the get VM command and just format on the name and the version. With Windows Server 2019, it should be greater than 9.0. So that way you know you're getting the latest and greatest. For Windows 10, it may be something like 8.3 as of the time of writing of this course. So it varies on the version of the guest OS as well. So an upgrade of the server OS or Hyper-V has very little impact on the guest VMs as long as your guest VMs are fully patched and are up to date. Microsoft and the Linux distribution vendors will make sure that you have the latest integration services for the Windows Server or Client OS and Linux, as we've talked about in the previous section about Linux and BSD. As long as you're running the modern versions of Linux or BSD, which have the Hyper-V modules built into the kernel, and you update that Linux or BSD VM through the traditional mechanisms available to you, then you have an up-to-date version of the integration services. Very, very simple, very effective. That was it for this section. In the next section, we talk a little bit about more operational-oriented tasks like monitoring, tuning, troubleshooting of your Hyper-V environment. In this 7th section, we continue looking at aspects of Hyper-V management. Specifically, we will look at what it takes to monitor, optimize, and troubleshoot Hyper-V. We begin by monitoring. In this lesson, I begin with providing an overview of monitoring a Hyper-V host or cluster, then shift towards performance and capacity monitoring. There are 3 core elements to monitoring your Hyper-V environment. First, monitoring the fabric infrastructure, so everything associated with the server infrastructure, the network, compute, connectivity, and storage. Second, performance. We talked a lot about how to provide predictable performance in Section 2, Advanced Networking and Storage. So how do you monitor the environment even if you did everything we talked about in Section 2, such as QoS? Third is capacity. With virtual infrastructure, this is a tricky one, but there are things you can do to monitor historical usage in order to help plan the overall capacity of the environment. There are built-in tools for monitoring, and there are tools from Microsoft such as System Center, as well as Microsoft's partners. So how do you pick a tool? I can't really talk about third-party tools just because there are so many out there, but I can help you decide between some of the built-in tools versus System Center. In terms of functionality, System Center provides centralized management and monitoring of your entire environment. The built-in tools are focused on standalone deployments. The built-in tools are agentless, therefore you don't need any software installation on the Hyper-V host. System Center requires agent deployments on every individual host. Perhaps the biggest gap of the built-in tools is the reporting capabilities. This is an area where System Center just shines. System Center Operations Manager, or SCOM, provides a wealth of monitoring capabilities for your fabric infrastructure, but it relies on management packs. Management packs provide operation management monitoring by providing application-specific monitoring and alerts. The recommended management packs for Hyper-V are those of Hyper-V, Virtual Machine Manager, failover clustering, and storage from either the storage vendor or Windows Scale-Out File Server Management. I do not go into Operations Manager monitoring as this is beyond what I will cover in this course. I could do a separate course just on that. I do walk you through real-time monitoring options available with the built-in tools. Let's talk about Task Manager. Task Manager is a great tool to understand what is going on with your server. It sometimes lies when the server is Hyper-V, however. For instance, consider the screenshot from Task Manager on the right showing CPU utilization of 34%, but the only VM running on the system is consuming around 0%. Where is the truth? First part of the answer is that when you run Task Manager in the parent partition, it knows nothing about CPU usage that is happening in Hyper-V or child partitions. Why? The parent partition is just another partition. To get an exact reading of CPU utilization, it would have to read the CPU utilization of every child or VM utilization. This is what the Hyper-V Manager is showing. To get this reading outside of Hyper-V Manager, you can use perfmon or Performance Monitor, and I will show you how to do this in the next demo. In this demo, I'll walk you through some of the Performance Monitor settings to get the accurate CPU utilization from Hyper-V and some of the virtual machines. So let's have a look here. You see in the Task Manager it says it's around 25% utilization or 24% utilization. But if we look at the only virtual machine in this system, a Windows 10 VM, it's around 0%. So obviously there's something running on the parent partition other than what's in the VM, but how do we get accurate reading from both? So let's fire up Performance Monitor. And in Performance Monitor, that's when we'll go ahead and add some counters that are relevant to both the parent, which is what you see in the background, but we will look for guest processor settings labeled as Hyper-V Worker Virtual Processor. That's where you'll see the two virtual processors assigned to the Windows 10 VM, and I will add these. Right now they're at 0%, but that's when you start seeing that performance. You see the system one at 20 some odd percent, and you'll see the other one in the different colors at the bottom associated with the Windows 10 VM. And the more VMs you have, the more you can add this worker processes to be able to view this. Next, we have a look at performance monitoring. To get performance data, consider getting the performance monitor counters for the Hyper-V partition, virtual and logical processors, as well as the IDE controller for Gen 1 VMs gets storage real-time performance monitoring. Additionally, perfmon counters for the network adapter and the VM bus. I will list the most important counters in the next few slides. First, for CPU, 4 counters here to help you determine CPU issues and how much time is each virtual or logical processor spending on a given process. Next, memory counters. Here we want to identify what issues, if any, are being caused by dynamic memory. Basically, we want to know if a VM is configured with dynamic memory, and it shouldn't be configured with dynamic memory because it has an underlying application managing the memory by itself. Those performance counters will help with that. Next is storage. Storage performance problems are perhaps the most common in a Hyper-V environment simply because storage is the most expensive resource of the fabric. Administrators tend to like to oversubscribe, and that ends up causing storage performance issues. These are the storage counters that I recommend. Basically, if you have clustered CSV volumes, read and write for SMB, and for file system read and write as well. Capacity monitoring now. Capacity monitoring is about knowing how much capacity is used, how much is available, in order to figure out when or if you will run out of your fabric infrastructure capacity. Unfortunately, this is not an area serviced by the built-in tools. System Center, especially when Virtual Machine Manager and Operations Manager are integrated, provide exceptional support here, including native built-in reporting for capacity utilization and forecasting. In the first lesson of this section, we looked at the options available for monitoring. VMM and Operations Manager provide the richest reporting and extensive monitoring and alerting. Built-in tools such as perfmon provide excellent support for real-time monitoring, but unfortunately very limited to no reporting. In the next lesson, we look at what you need to know to optimize Hyper-V. This time, we look at optimizing Hyper-V. I begin with general recommendations, and then I provide some very specific recommendations with respect to optimizing your fabric components, including storage, network, memory, and processor. If you decide to skip to the rest of the lesson, having learned only what's on this slide, you will have learned the most crucial recommendations relative to optimizing Hyper-V. But don't, because there are lots of useful information in the remainder of this lesson. First, Server Core. Server Core is not only the default installation option, it ships with a smaller installation footprint, and it's great for Hyper-V. Just choosing this option already provides a more optimized installation for Hyper-V. I've said this before relative to other elements of planning and deployment, and I'll say it again. Start with default options and choose configuration drift from default very carefully. This goes to the page file as well. Finally, anti-malware or antivirus software is a huge culprit of performance degradation on Hyper-V servers. If you are going to install one, Ensure it has the AV exclusions published by Microsoft to minimize the impact of the AV software. To optimize storage, begin by choosing the newer VHDX disks and not VHDs. Really, all of Microsoft services now, except maybe for Azure, support VHDX format. Similarly, for Gen 2 VMs, basically just use your newer virtual hardware features. Next, make sure you understand the workloads on your VMs and choose dynamic disks only when the workloads do not need disk expansion very regularly. Otherwise, go to fixed disks. RAID level. RAID, especially RAID 6, has huge performance hit on the storage subsystem and is very visible to VMs. RAID is necessary, but RAID 6 is really an excuse to poor storage design in my view. Review the storage lessons in Section 2 before deciding to go to RAID 6. Do consider software-defined storage solutions such as Spaces and S2D with RDMA as a cost-effective solution to storage capacity and performance. Finally, the best way to ensure guest VMs have predictable performance is using storage quality of service. If you are statically assigning memory, there isn't much to optimize. Presumably, you had a good reason to use static assignment for memory. For dynamic memory, there are always two burning questions. Should you use it? And if you are you using it effectively? In the last lesson, I gave you some performance counters you can use to answer these questions. I'm not a fan of overcommitting Hyper-V's memory, as this is asking for trouble if or when the server is restarted, and some of the VMs just won't start due to memory shortage. Keep the memory total assignment very close to the physical memory installed in your server. In my experience, it is very difficult to saturate well-designed and modern Hyper-V network. A modern Hyper-V network is anything using RDMA and or 10 gigabit or higher networking. Stick to the planning recommendations we went through together in the first two sections and you will run a very reliable Hyper-V network. If you are a seasoned Windows Server admin or came to Hyper-V from another virtualization platform, then you may be familiar with some of the tweaks you had to do on the NICs, such as disabling TCP offload. Again, leave these as default. Only disable them if and only if the Microsoft support engineer is recommending you do so. NIC teaming is a great way, again, to improve resiliency and performance to all your VMs. Finally, just like with storage, use modern features such as the synthetic network adapter and not the legacy virtual adapter. This recommendation is really for legacy releases of OS such as older Linux distributions, although this is not much of an issue with the Windows Server 2019, especially with modern Linux and BSD distributions. Finally, the processor. Since most CPU mappings with Hyper-V is static, i.e. one virtual CPU for each physical core, not much optimizing is possible. The only exception is with processor features such as Intel's hyperthreading, which shows up to Hyper-V as another processor. Hyperthreading isn't a CPU core, so keep that in mind when assigning vCPUs to VMs. If you suspect that a processor is a bottleneck, use the performance monitor counters I discussed in the previous section to narrow your troubleshooting. One other optimization with respect to the processor is the power optimization. Many servers, for whatever reason, ship with CPU power savings turned on. So make sure and disable this when you provision a new server. We are at the end of this lesson. The key to optimizing Hyper-V is to actually stick to defaults and only deviate when you know precisely the why. Storage is the only area where you will have lots of options to optimize. Modern virtual storage features such as the SDS provide significant performance gains at lower cost. In the final lesson of this section, we go through some of the capabilities available to assist you in troubleshooting your Hyper-V environment. This is what we go through in this final lesson in this section. I first explain some of the most common problems you may encounter and then give you some tricks on how to go about troubleshooting them and any other issues you may encounter. The first step to troubleshooting anything in your data center, for that matter, is to ensure that you have a good deal of useful monitoring and alerting. If you are monitoring the counters I described in the last lesson, and hopefully getting some alerts on them should they go beyond acceptable thresholds, then you are more likely to know about problems as they happen versus when someone calls you to tell you that there's a problem. As you can probably appreciate by now, Hyper-V touches a lot of components in your infrastructure, and as such, it can be complex to implement and maintain. Additionally, with the wealth of hardware support with Windows Server, it can be tricky to write and maintain drivers for a complex solution like server virtualization. Driver reliability has improved dramatically with every release of Windows Server. That said, if you think of all the hardware parts and components in the server that Hyper-V touches, you will occasionally have driver issues. This is where HCI has a clear advantage, as this is built and delivered as an integrated system. Driver updates are tested against the solution versus a single server component. In my experience, the most common problems arise when one VM is over-consuming resources of a server, network, or storage. This is the noisy neighbor problem, and it can only be resolved by limiting or capping resources of a VM with QoS. If you follow the recommendations in this course, including these about implementing storage and network QoS, you will surely run a stable environment with very few problems. Okay, so you've done all the planning you could, but you still have a problem when operating the environment. What do? The first thing to do is consult your monitoring tools to help you isolate the issue in order for you to dig deeper into the cause of the problem. You do this in the same way you troubleshoot anything in Windows, that is, by reviewing your event viewer logs first. There are really three areas of focus for logs in Event Viewer: the system logs for Windows logs, the failover clustering sets of logs under Application and Service Logs, Microsoft Windows, and Hyper-V. So let me show you in the Event Viewer how to go about doing this in this Event Viewer demo for troubleshooting Hyper-V. Fired up here the Event Viewer on my Hyper-V host. First thing I'm going to do is I'm just going to create a custom view with some of the more interesting logs for troubleshooting Hyper-V. You probably wouldn't want to do this in a production environment because that's just generates too much logs, and we'll probably get a warning about that, but I just want to show you a sample of the view and then go deeper in every single one of the logs. So the system log, as I mentioned, in Windows logs. Next, I'll expand the application service logs under Microsoft, Windows, and there's really two areas of focus here, the failover clustering and Hyper-V. So there's a bunch of stuff for failover clustering, different logs. I'll go ahead and select all of them. Some of them are specific to storage, like also shared volume ones. Some are specific to the management, but I'll go ahead and select all of them, just show you what's available. Next, I'll go ahead and look for the Hyper-V ones. So there's a number of them, and you'll see Hyper-V splits up the logs based on different functionalities. So another one for the vSwitch, the workers, so that's the specific VMs, the hypervisor, the guest drivers, the configuration. There's a lot of them, but let's do all of them. And I'm not going to filter by event IDs or the event level. So I'm going to capture everything just to show you what's available. And yes, I do get a warning that this can take a long time, but this is one standalone Hyper-V server that I have. I'll go ahead and give it a name and click OK. It's relatively quick on this server. But you can see here, there's over 100,000 events generated from this one. Let me generate a filter to show you one event that I know is of interest that I mentioned and spoke about is event ID 55. I get the same warning about having a lot of events, so that's fine. This is the kernel processor power. So as I mentioned, there are many instances where servers shipped are configured with power savings, and you will see here in this event viewer entry, it will not show 100%. So when that happens, you have performance limitations on the power of the CPU in the firmware. You'd have to go and change it in the firmware. Other logs of interest. So let's scroll down if we don't want to use the view, the failover clustering, and the Hyper-V one. The VMMS one is one that I look at frequently. This is for Hyper-V management service. If there's any issues with the service, for instance, VMM is not able to connect to it, or the Hyper-V manager, this is where you would look at. It gives us operational entries every time it creates, for instance, a a VHD file here. So, and the vSwitch settings. So every time there's a configuration change, it shows up here as well. This is in a nutshell. Obviously, there's a lot to look at, but those are the logs of interest that will help you in troubleshooting your Hyper-V environment. So how was that demo? If you're a seasoned Windows administrator, or if you've done any Windows administration troubleshooting, that should be very familiar to you. That was intentional. That's what's great about Hyper-V. In the next and final section of this course, we will talk about containers. We are going to talk about containers. First, I will begin by introducing containers. Why are they important for you as a Hyper-V administrator or architect? Next, I'll talk about containers on Windows servers. You'll see there are two types of containers on Windows servers. And finally, I will go through a brief introduction on how to deploy containers on Windows servers and Hyper-V. So let's begin by introducing containers. First, I will introduce what containers are about. What are the benefits of containers? Why are they becoming so popular and all the rage, especially with developers? And I will want to go through some terminology that you're familiar with the terminology. So as a Windows and a Hyper-V administrator, you understand the terms when a developer who is using containers comes and speaks to you. First, what are containers? In case you're wondering why am I introducing containers in a Hyper-V course, there are some similarities between containers and virtualization. Recall that Hyper-V is a hypervisor that abstracts hardware and virtualizes it. So really, Hyper-V is about hardware virtualization. Well, containers are similar in that they are about operating system virtualization. So some components of the operating system become virtualized, but as you'll see, some components are shared between containers. This is probably the best description to help you understand what containers are about. You have the host operating system on which there's a kernel on top of it. That kernel has an user mode. In user mode, you have binaries and libraries. And in there, you have the container applications. The container applications and the binaries are bundled together in user mode that is dependent on the kernel. So what does that mean? It means the containers have to be the same version of the host operating system, since the different container applications will share the same host OS kernel. So how is that different from virtual machines? So in a virtual machine, you have server infrastructure, just like you would with containers, on top of which there's a host operating system, just like containers. But then you have a hypervisor, in our case Hyper-V, that goes on top of the operating system. In Hyper-V, you deploy guest OS VMs or guest VMs. Each one has an operating system that may or may not be the same as the host operating system. We've seen, for instance, Linux and Windows 10 VMs that are on Windows Server 2010 host OS. And in these guest OS VMs, you have your binaries, libraries, and applications. So you see some similarities with the containers, which is OS virtualization again, but instead of a hypervisor, you have a container engine, which is a piece of software. In our case, this would be Docker. And in that container engine, that's when you have your shared libraries that are shared between different applications and could have multiple containers with additional applications. So let's have a look at some container terminology. First is Docker. Docker is a name of a company that produces the Docker engine that is being used in Windows Server to manage containers. Some additional terms. Orchestrator is a piece of software that goes on top of the container engine, and its job is the whole management and operation, orchestration, scheduling, scaling, failover, clustering, networking. It does a lot of things for those containers. Container image, just like an operating system image that you're familiar with, container image is an image or a grouping of applications, files, and any customization layers. A container registry is simply a repository of container images. So when you are deploying a container in your Windows Server environment, you can pull that image from a repository. Some of the familiar ones is the Docker Hub, and in Windows Server 2019, there's a new one. We'll see that a little bit later. Finally, a sandbox. Any writable action of a container is saved in a sandbox. What happens with the container is because that kernel is being shared by all containers, that kernel is read-only. Anything that requires any write operations, that's where it's being saved in a sandbox. So what are the benefits of containers? Why have they become all the rage, especially with developers? Really, containers were built to try and solve a few problems. One of the main ones is what happens when a developer develops code on their laptop or desktop and then wants to promote that into a dev environment, into a production environment afterwards. Well, those environments are not the same. So what ends up happening is that code that the developer wrote will not work in the development environment or test environment or production environment. So one of the ways to solve that is by creating a container. It's self-contained, it has an application layer, it has the dependencies. As long as you're deploying it on a known host OS, which is managed by the Docker engine as well, then you are more certain that that code will run into that target environment. So that's a big problem that developers try and solve by using containers. The other thing is containers push for smaller, lightweight applications. As you make them in the images are very lightweight. That's one of the use cases for Nano Server and Windows Server Core as well. Because the applications are very lightweight, smaller images, they're very suitable for microservices architecture. Again, something that developers really, really like about containers. So that's it for now. I just wanted to introduce what containers are about. So just keep in mind, this is OS virtualization. What you can do with containers is lightweight applications or lightweight services that become bigger applications and are managed independently that way. Developers love them. As Windows Server Administrator, begin to like them because they save you a lot of headaches when developers promote code from one environment to another. Next, we will look at the specific use case of containers on Windows servers and the types of containers available to you on Windows Server 2019. Containers on Windows Server. Two types of containers available in Windows Server 2019. Those are Windows Server and Hyper-V containers. And we will go on the requirements needed to deploy either one of these types of containers. First, let me explain to you the differences between these two types of containers, that is Windows versus Hyper-V containers available in Windows Server 2019. In the last lesson, I talked about what a container is. So in the case of Windows Server 2019, as the host OS, you have a Windows Server 2019 kernel on top of it, and you have user mode on which there are libraries and container applications running under the Docker engine. This is what a Windows Server container is. There are dependencies between container, the binaries, the libraries, and the kernel running on Windows Server. Containerized application is a Windows Server 2019 application and only a Windows Server 2019. It cannot be, for instance, even a Windows Server 2016 application because it is sharing that kernel. This is what Windows Server containers are about. So what if you wanted a situation where you're developing an application for Windows 10 or Windows Server 2016, or you want to test the application for Windows Server 2016 and 2019, because as a developer, you want to make sure you have that wide or broad support of your application. So with Windows Container Image, you would have Windows 10, Windows Server 2016, or Windows Server 2019. Yes, Windows containers do work on Windows 10. You can have your customization layer. So for instance, if it's a web application, so you would need a dependency on IIS, and you'd have your application. Hyper-V containers are a little bit different. So on top of the host operating system, you have Hyper-V, and you can deploy each container image in its own specialized guest OS VM. So you'd have a separate container instance. So what does that give you in terms of benefit? I think you can probably guess one of the main benefits. I talked about a constraint of the typical Windows containers, which is that the container application must be of the same OS version as the host OS. Well, with Hyper-V containers, that is not a restriction. In a nutshell, you can put a Windows 2016 container application on a Windows Server 2019 host OS as long as it's using the Hyper-V container isolation. This is a very, very cool feature as a Hyper-V architect or administrator, but also as somebody who wants to promote containers in the enterprise. That is one way where you can promote developers for them to use containers for cross-OS development as well. You can look at the version compatibility at the link that I show at the bottom of the slide. So what do you need to run containers on Windows Server 2019? Well, as a minimum, you need Windows Server 2019. And if you are using Hyper-V containers as that layer of isolation, then you need the Hyper-V role. You don't need it otherwise, but if you want to provide that support for additional operating systems and have that extra layer of isolation, then you do need the Hyper-V role. And keep in mind that the container OS images are only for Nano Server and Windows Server Core. Containers do not support GUI. What about Active Directory? Windows containers cannot be domain joined. That is about the only or one of the very few cases where Microsoft has a Windows deployment that cannot be domain joined. Well, how do you manage groups of containers and container applications and clusters if you cannot domain join these applications? Well, there's something called the Group Managed Service Accounts that was introduced around Windows Server 2012 that can be used instead. And we'll talk about how you can use that and how you can deploy containers using the Group Managed Service Accounts. These are the steps in a nutshell. First, create the GMSA, give the container host access to it, again through PowerShell. We'll look at that shortly. Then you use the credential spec PowerShell module, store the settings needed for GMSA, and finally you start the container with the credential spec attribute to let the container know that it's using a GMSA. Next, a word about antivirus applications. Antivirus, I've said it several times in this course, has a tendency to slow down Hyper-V installations if not tuned properly and not optimized properly. Same thing goes for containers. You don't want the antivirus to go ahead and scan all the container images, especially if you have a large clustered application. You need an antivirus application that is Windows container aware and supports it. Docker luckily has a list of which applications support Windows containers at the link I provide here. Containers on Windows Server and Hyper-V come in two flavors. That's the Windows container and Hyper-V container. Use Hyper-V containers to provide a wider support of container operating systems and to provide additional isolation. Very, very, very cool feature with Windows Server 2019. In the next video, how to deploy containers on Windows Server 2019. Container deployment. How do you go about deploying containers on Windows Server 2019? How do you go about configuring the GMSA for Windows containers? And how do you go about deploying Docker on Windows Server 2019 so you can host your containers? First, your GMSA. Again, why do you need GMSA? Because Windows containers cannot be domain joined. GMSA is only created with PowerShell. You create GMSA with a new AD service account, so you need domain admin credentials to do this. You provide few mandatory parameters, give it a name, so in my case hvconf for containers, provide a DNS hostname that is required for the name resolution of the host name. In my case, it's my domain controller. Then you actually provide which host OS servers will have access to this GMSA. So that's defined. In my case, I created a domain group called the GRP HV servers, and those servers and computer objects are hosted in that group. So once I do this with a new AD service account, those servers will have access to GMSA. So let me show you this in this demo. I have Hyper-V PowerShell open. So first I want to create a key for my Active Directory. So I do this with add KDS root key. If I don't do this, I cannot create GMSA accounts. I will use the effective time. In my case, I only have one domain controller. Doing the add KDS root key usually takes 10 hours to propagate to all your domain controllers. I'm going to say add hours minus 10, so it takes effect right away. Don't do this if you have a very complex environment. I have a GUID now for my key that I can use to generate GMSA accounts. So let me clear that out of the way. And as I mentioned in the slide, you create the GMSA with the PowerShell commandlet new AD service account. I will give it a name, hvcont for container. I will specify the DNS host entry, which in my case, again, is my domain controller because I have AD integrated DNS. Next, I will specify the group that I created that will have access to this GMSA. Again, I put all my Hyper-V hosts in there since I will be using Hyper-V containers. So the domain group name is group grp-hv-servers. Finally, I specify which crypto algorithms are supported. I will just actually support all the ones that are available for me, so RC4, AES, 128, and 256. That's it. There you go. Now I have created my GMSA account that I can go and use in my containers. Now that I have configured my GMSA, I will go ahead and show you how to go about deploying Docker on Windows Server 2019. By the way, you can still deploy Docker without GMSA. It's not very useful to run containers if you don't have GMSA for any sort of clustered application. So first we want to install the Docker Microsoft provider. I do this with the install module. The name of the module is Docker MSFT provider. Next, once the provider has been installed, I go ahead and I want to install the latest version of Docker. I do this in PowerShell again with install package-name Docker using the Docker MSFT provider. Again, since this requires the installation of an application, you need to have an elevated PowerShell prompt, as I mentioned before. Once you've done this, you will get a prompt to restart the computer. So go ahead and restart the computer. Once you've restarted the computer, you are ready to grab your first image from the Microsoft Container Registry. This is new for Windows Server 2019. I talked about a container registry in the first lesson of this section. Microsoft introduced a new registry for 2019. In this case, I want to grab the server core image from Microsoft, long-term servicing channel 2019, and that will give me the full server core image. So that's over a gig in size. So you want to do that on a good connection. Alternatively, you can just grab the nano server image if your application supports nano server. Let me again do a quick demo and show you how to go about doing this. I have my elevated PowerShell command prompt ready. So the first thing, again, I want to do is install that provider. I do this with the install module in PowerShell and the name of the provider, the Docker MSFT provider, and specify the repository, the PowerShell gallery repository, and I want to force this. If you already have NuGet on your server, you will not get this message. I don't. This is a fresh installation in my case. And there you go. The Docker MSFT provider is now installed. So let's clear that out of the way. And with that installed, then I can go ahead and install the Docker package from the PowerShell gallery. I'm being asked about an untrusted source. Fine, I do trust the source. And you see here, Docker installed, Docker EE for use with Windows Server. So we are now ready to get any Docker images. First, let's restart the computer. After the computer has been restarted, I can issue the get package-name Docker and the Docker MSFT provider just to make sure that it has been installed correctly and make sure this is ready. And there you go. It shows me the correct version. So my server is now ready for containers. Containers are a big shift in how developers develop applications. You only scratch the surface. There's a lot more for developers to know about containers and deployment and how to develop the applications and dependencies, etc. And this is a wrap, folks. I hope you found this course very beneficial. Hyper-V is a really, really cool product. It is a massive product. As you saw, it has a lot of dependencies. It touches upon a lot of different things: networking, storage, Active Directory, monitoring, backups, a lot of things. There's a requirement for you to step up as a Windows Server administrator and to become a Fabric administrator. This is a shift in our industry where, as a Windows Server administrator, you become more knowledgeable about some components that in the past you wouldn't have had to. You become a Fabric administrator, is more knowledgeable about all these dependencies within your environment. You become even more valuable to your employer. I hope you find this very helpful. Again, reach out to me on Twitter, ADIYQ, ADIYQ. Let me know what you thought about this course and what you'd like to see in the future. Thank you very much.